This is the first super summer session of 4 sessions that will be talking exclusively about construction, construction decisions, constructability, and how the A-GaME can help us with our needs to those ends. We are stepping into the contractor's boots today. Yeah. Is this the? We'll continue with this. There we go. Yeah, just starting off here, just a few notes here. You know, the contents of this presentation, in fact, the entire session, as it relates to what we say from FHWA's standpoint, from my perspective, or for what you hear from me, from Derek, from Dustin, or Silas, none of the materials that we're going to present in any of these sessions or today has the force or effect of law and is not meant to be binding in any way to the public. So the information that we're presenting is information only. And one other note, that we, with the US government, don't endorse any products or manufacturers. You know, any trademarks or manufacturers' names that you see here are meant to be informational, and we don't, they're not intended to reflect any preference, approval, or endorsement of any one product or entity. These sessions, today we're going to kick things off by getting a perspective from our contractors. We have a great lineup today of speakers, which we will get to shortly, but we want to sort of gain that perspective in this first session. We're going to continue on in July with a session looking specifically at geotechnical uncertainties and how we can reduce those, which all of these themes will be coming up today during the discussions. We have an issue with how we do investigations, and you know, we will be talking more about this, but I think most of the people who do geotechnical work recognize that we are driven often by the initial project requirements, and we don't always get information to the contractor that they need for bidding purposes or doing their job during construction. So we are sort of looking typically at minimum requirements from the AASHTO code on you know, what the minimum requirements for subsurface investigations are, but you know, we have a gap, and we need to talk about how we get information to the contractor and think before we get there, before we get to construction, what needs are there for our contractors that we need to anticipate and discuss. So the final topic that we will be talking about in session 4 is going to be owner-only forum, where we're going to discuss what we've heard with the first 3 sessions and synthesize that information and come up with a game plan, action items, making it happen, putting the ideas and improving practice. So there will be a different format for those. It'll be more of a discussion format for our state DOT representatives and other owners. One other point I want to make here is that there is a publication, and we will put a link to this publication in the chat. But there was a publication that came out years ago on geoconstructability, which is an owner's primer for obtaining essential geotechnical information for construction. And there's a lot of good information in this document that is useful. So take a look at that, and we'll be talking more about that throughout the sessions to come. So what to expect today? Today, oh, we have one more note. Recognize that we are having a discussion during this first session, and all of the comments and opinions that we share are from individuals, right? So the viewpoints expressed are of those individuals, and they're not necessarily represented or are representative of FHWA or the contractors that are not talking here. So we're having a discussion, and just realize that these are opinions and thoughts from individuals. This session is also being recorded and will be available for future viewing. So today, I think we had missing a slide here. Yeah, so what to expect today. We have a great lineup of speakers here. Be thinking about these topics as we go along here. We're going to gain, we want to gain a perspective or an understanding of the contractor's perspective on geotechnical related issues on the A-GaME concept, and what information is important and what problems our contractors experience. We're going to be talking about risks and decisions that are being made from the needs for bidding and construction decisions, looking at the A-GaME, the fundamental part of the A-GaME, which is reducing risks by characterizing conditions better before construction and not necessarily transferring them. So that's going to be another point that to look for in our discussions. And finally, the value that the contractors bring to us, their experience and insights that we can tap into. Be looking for that in what you see and hear from our speakers today. So, with that, I just want to mention that, and I have not introduced myself. My name is Ben Rivers. I'm with the Federal Highway Administration with the Resource Center. I'm joined here today in moderation capacity by Mary Dodine and Derek Dassenbrock. They will be helping me looking at comments coming through the chat pod and the Q&A pod as well. Our guest speakers, very fortunate to have Steve Saye with Kiewit, Jim Harmston, who's retired specialty contractor from North Carolina, Brian McGlynn from Menard, and Rick Deschamps from Nicholson Construction. We also have 4 peer panelists, and these are representatives from the owner. So they are going to be engaging with our speakers during the discussion part, and occasionally maybe during the presentations as well. But we have Peter Davich, we have Sarah McGinnis, Kevin White, and Dustin Robbins joining us for part 2 of this session. And we'll introduce our panelists during the part 2, and we'll introduce our guest speakers more formally as we get to them, which is we'll reach that point. So Steve, if you don't mind taking over and sharing your screen, and I will, while you're doing that, I will introduce you.
So I got a message that says I can't start screen share while other participant is sharing.
You should be good now that I'm done sharing. Try again.
Very good. Stephen Saye is a senior geotechnical engineer with Kiewit Engineering Group. Steve has been a registered professional engineer for over 40 years and has spent his last 16 years with Kiewit, primarily working on design build projects and engineering, procurement, and construction, or EPC projects in North America. He is the past president of the Nebraska ASCE group or section and is a life member of ASCE. Steve will discuss lessons learned associated with the ground improvements to mitigate soft ground conditions and support the reconstruction of Interstate 15, the Interstate 15 project in Salt Lake City prior to the Winter Olympics. ASC named this project the Outstanding Civil Engineering Achievement for 2002. Steve?
Mary, can you see the slides?
We can. And you have the floor. Thank you, sir.
Well, thank you. So 25 years ago, I was a design engineer for Clyde, and we were selected by the Kiewit-led joint venture to provide the geotechnical services for kind of the northern half of the project. I had the great fortune of participating all the way through the estimate level design and the preparing of the estimate. Then we were awarded the project and spent a good part of 4 years in Salt Lake City, getting the design prepared, working through the issues during construction. And then we had the good fortune that UDOT sponsored a 10-year monitoring program of the performance of the ground improvements and had the opportunity to work with and be aware of the results of that monitoring so that we have a better understanding of how those designs work. And then 17 years ago, I came to work for Kiewit Engineering. Period. Have been working on design build projects, both from the estimate side and the pre-bid designs and the final designs, and then the issues during construction. So that's my perspective of looking back of the work for the ground improvements at I-15 and what lessons I think I would bring and would want to share to you. A little excerpt through there. At that time, it was the largest highway contract in the U.S., particularly for design build. It went over 4 years. It had a fixed completion date that was tied to the opening ceremony of the Winter Olympics that was met. It had a tremendous amount of embankment, tremendous amount of ground improvement. As we said, it was recognized by ASCE. In the time that we have through here, there's a series of things that I hope to convey with you. The first one is the importance of the piezo cone test in soft ground projects. The importance of defining what we think the post-construction design criteria would be that would guide the pre-bid evaluations and the final designs. A bit of a discussion regarding sample disturbance and how that's so important on soft ground projects, and recognizing that a key component of meeting the schedule was the use of prefabricated vertical drains or wick drains. We'll talk a little bit about what we learned there. An issue of particularly from design and from construction about the long bridge transition slabs we had, and then a final discussion about availability of electronic information at bid time. And in the 1960s, UDOT essentially raised the interstate as it went through most of downtown Salt Lake City. And the construction efforts were to both raise the existing embankments and widen them. And that had the challenge that we knew that we were going to need to force more than 1.5 meters of settlement during the construction period. The issues of maintaining stability while we were bringing all that fill in and deliver it on time. And UDOT, I think, correctly identified that the design build contract was the best way to reach those challenges through there. And from my perspective, we use the piezo cone extensively to provide, and it had the advantages of providing nearly continuous data profiles. 25 years ago, we used it to try to assess selected geotechnical properties. Today, we would use it to do more, and I think the A-GaME is is focused on trying to do more with that data. We used it extensively to both to supplement and to extend the available lab data. And then the local geotechnical engineers taught the team about how to easily identify the soil stratigraphy to be able to understand what the critical units were. And I'll repeat this in the end. As we were preparing the bid, we didn't have the data in digital format. It was much of the squiggly lines on the graph that we can see through here. And for all current projects, the access to the digital records are probably one of the first things that we'll always want to ask for. And Mary, I believe that these slides are going to be presented to the participants. Is that correct?
Yeah, we haven't specifically discussed that. There will be the recording, obviously, but if you guys are willing to share your slides, we can certainly distribute them. I think it would be on an as specifically requested basis, so you could just email me.
So,
yeah.
And in this particular issue, we can see the cone data in the right-hand two slides, the myriad of data for the conventional index properties, and then the word descriptions and the geologic materials on the left-hand column. And for our particular project, the Lake Bonneville clay and the Cutler Lake clay deposits were really the bad actors that drove all of the concerns for stability and settlement through the project. And you can see in the interbedded glacial deposits the spikes of the Q values through there that are indicative of sand layers and silt layers and how they might be of importance in our understanding of the behavior of the wick drains. The other point that I would make that was something that Kiewit generated is that in the soft ground projects, we developed what we thought were the post-construction settlement design criteria that we were going to use as a basis for our calculations and for our designs. And that was our method as the design builder to communicate to the owner kind of the expectations of the settlement calculations and what we were striving to do. And in those instances, the feedback from UDOT was that the bump at the bridge was considered to be a critical condition, certainly for the long-term settlement. We had a defined maintenance period of 10 years. And so that we worked with UDOT of identifying an allowable bridge settlement of 51 millimeters and the roadway adjoining the bridges of 75 millimeters. Grant Gumo at UDOT was part of our design team, and he's taken this approach to UDOT, and in their design build projects currently, we will see a similar set of guidelines as to where the owner will establish these expectations for the ground improvement designs of amounts of settlement, distribution of settlements, and specific time frames. And that's certainly something that grew out of I-15 and we believe is appropriate for owners to use in all ground improvement projects, of being able to communicate the target values for those designs. Now, an important part of the I-15 efforts were, most of the engineering calculations that we did involved around consolidation properties, the amount of settlement, the long-term settlement, the rate of settlement through there, and those those inputs to those calculations were all based upon the laboratory test results that we had. And certainly with the fixed completion date, the rate of settlement and the corresponding durations of settlement periods to force this 1.5 meters of settlement out during construction was key to an understanding of the schedule. And yet, as we dug into that, we found that sample disturbance was a real impact for those pre-bid assessments through there. And what I mean by that is we used at that time, the Norwegian Geotechnical Institute approach for looking at the settlements, and it's essentially looking at the strain of that we measure in the odometer test as you're loading it up to the effective overburden stress. And the left-hand sample is what we would consider a bad sample. We're seeing strains of about 7%. And on the right-hand side, we would have a good sample, and those would be strains of about 2% through there. And if we went back through the boring and the laboratory data that we had at bid time, you can see from this graph that almost half of the samples would be discarded if we used a criterion of 4% of strain. And this particular graph then would show that we tried to do things and improve those during the bid or during the design phase, and we still had what I would consider a failure rate of about 20%. And in that effort, we would say that it's really difficult to develop reliable assessments of settlement properties if the laboratory samples are disturbed. And you're probably going to get a picture or an appraisal of the ground conditions that are probably too pessimistic. But you're not going to make the right decision if you're looking at things regarding settlement problems. So I would suggest to you that every project include an assessment of the issues of sample disturbance, and in some cases, non-standard approaches may be necessary in those instances to be able to get good samples. And an example I would have is in the work that we've done down post-Katrina for the recovery of New Orleans. The New Orleans district of the Corps has come up with a system of 5-inch diameter Shelby tubes that they push continuously. And those would rank now as probably the best samples that I've seen in routine practice. And certainly in New Orleans, you need good samples through there. For I-15, we focused on rotary wash borings, 3-inch piston samples. Many of the tests were run at MIT, and they had radiography to be able to select the specific locations of the samples. MIT has a system of cutting the tubes and debonding the soils, and I would look to you for have you look at a reference Ladd and DeGroot, and these references are attached at the end of the slides as probably being the standard of practice to be able to go get good samples for testing through there. The other thing from the perspective that I would have you understand is this project was unique in that we had a fixed completion date. We didn't have an opportunity of completing the project 6 months later because the settlements went on too long. And from the experience in the 60s with the displacement sand drains, clearly vertical drains were going to be needed if we were going to be able to drain the water out properly. The 60s constructions went on and had settlement periods of 500 to 1,000 days. We looked at the wick drains to be able to go in through there, and had the idea that rather than 2 years, we had a need of being able to push the settlements to occur in about 90 days. That was another unique thing about the I-15 project, is that we were needing to maintain the traffic flow during construction. So we really only had access to half of the roadway at a particular time. So we had to build half of the project, flip the traffic onto the new construction, and build the second half of the project. And in these instances where we had problems associated with stability, that left us with about 90 days to be able to go in through there. And many of you that have worked with trying to look at surcharges and pre-compression and ground improvements. It's really the duration of the second stage that really kind of drives how over consolidated the soils are and how much improvement you're going to have in the long-term settlements through there. And so particularly from the estimate and then from the design, the key factor that we had was trying to understand what the right drain spacing was through there and what those settlements were. We had, fortunately, some experiences here in Omaha of a project that was built in the early 80s. And we took those experiences through there, and we draw the conclusion that from a construction standpoint, we had to have a good understanding regarding what was the soil disturbance and what was the reduction in the permeability of the soils caused by the installation of the wick drains. What was the mandrel and the anchor configuration through there? And what we can see in the upper hand is an example of the mandrel for our project here in Omaha, relatively large anchor. The center, it would be a synopsis of the anchor that was used for the Interstate 15. And you can kind of see that it's a little more compact situation through there for the anchor and the stiffening arm and a much shorter bar. At I-15, we had an option of looking to try to do a plate anchor or to the bar anchor, and we'll talk a little bit about the decisions to go through there. And then after I-15, I was involved in the ground improvement for Woodward-Wilson Bridge, and you can see that in that particular instance, we had a configuration that was even more compact and worked even better. The key concern that we had pre-bid, and I think a key lesson learned from the ground improvements at I-15 is that you could put the wick drains too close together, that the impact of this disturbance that goes on from the mandrel and the anchor combinations overwhelm the benefits of putting the wick drains closer together. And in this particular example, we actually did a test fill. It was in the first phases of construction at I-15, and we put the drains in at 3 different spacings, and at the middle spacing we had 2 different anchor installations through there. And then you can clearly, and the dashed line on the graph would be the theoretical calculations, based upon the settlement behavior at the larger drain spacing. And by looking at that graph, you can see that when we moved from 2 meter spacings to 1.5 and then to 1 meter, the time for settlement didn't decrease. And that would say that the disturbance that was caused by the mandrel and the anchor at the closer spacings obliterated any benefit of putting the drains at a closer spacing. And then I'll refer to a publication that we put together in 2001 that tries to go in through there and provide some criteria of what that excessive disturbance line would be. And there is some math with which to be able to judge what too close is regarding the installation of wick drains. But clearly, a key lesson of I-15 is there are limits as to how fast you can make the settlement occur when you're using wick drains and in projects, so that it essentially says that you have to select what that critical drain spacing is. You have to look at your mandrel and anchor configurations through there, and then there'll be a settlement time that you're just going to have to live with because it's not going to go any faster. The other thing that was, I think, looking back on the project and looking at the long-term monitoring that UDOT has done after construction through there was is that the now 20 years later, the project rides very well. And a key component of that is that we recognized that we had to do something structurally to address the bump at the bridge. And we had what was called on the project a jumbo slab, but we had a reinforced slab that was 16 meters long that provided a transition from the grade supported surcharge ground and the pile supported abutment area. Now, since then, Brioude and others have looked at a tolerable bump as being about a slope in 1 in 200. And that's essentially, we believe, what the jumbo slab has provided through there. And I think anybody that has gone through the section of I-15 would concur. Certainly, UDOT would identify an acceptable performance through there. And yet, in other projects that I've seen after I-15, I find in the design build setting projects that oftentimes this transition slab is overlooked, and many designers and contractors want to go in through there and use whatever the standard section is. And a further lessons learned I would have is if you have a soft ground project, you really, as a designer and a design builder, need to look at what is the length of the transition slab, how is that designed, and is that really compatible with your expectations and calculations for the long-term settlements of the areas that you're preparing in other manners through there. Other lessons that I would have for you is to have a recognition. Phased construction creates a myriad of challenges, particularly as it would relate to access and surcharge placement and not being able to cover all of the embankment at one time. Lots and lots of edge effects and all that. We handled it for I-15 through the design build process, but there were many instances as to where specific coordination was required to be able to maintain the element of the access ramps and the movement of traffic and the maintenance of traffic, and many miles of temporary walls that were needed to be able to go in through there to be able to support the surcharge to allow the phases through there. And I would also have you recognize that as the thickness of the soft layer or the consolidating layer, as it gets deeper, it makes those problems be more and more important. From a perspective of 2020, I would offer you that it's increasingly important in the projects that the project data be available electronically. I know that's the discussion point of the A-GaME, but certainly Git logs and CPT records electronically are just important. The design builders and Kiewit would be looking to input the information into a three-dimensional system such as MicroStation. So all of the information electronically is important. You need to have survey locations because in this world of 3D design, we need to know the position of the borings and the position of the soil layers in the three-dimensional system through there. A few concluding comments through there. I hope you come away from the conversations with the idea that all soil samples are not created equal, and that particularly on soft ground projects, but I would believe that all projects, that the DOTs and the designers and the design build teams have to go in through there and make an appraisal of whether sample disturbance has occurred. And we've given you at least the way that we've used that at I-15. And that successful settlement calculation, and that means being able to predict what the behavior of the ground is going to be is going to require or does require careful scrutiny of all of the data and the considerations through there. So I thank you for your time through there. I understand that we'll have some questions in the screen. I've got a contact if people would like to do that. And then the last page is I've talked about what I think are a series of key references that we use for designers and as a takeaway of ways that the audience can come in through there and gain a good understanding of what we actually did at I-15.
Excellent. Thank you very much, Steve. Great presentation. A lot of thought-generating content, especially in looking at the value of in situ test and how that certainly can help characterize the problems that you face there. So just a few reminders here. Number one, we have a poll active right now that you can take. If you just click on the poll button at the bottom of your screen, you can take that poll. So please do that. We're not going to look at those results until part 2, but that will actually guide us in some of the discussions. Also, if you have questions to our panelists and speakers, as you think of them as presentations are going on, feel free to put your questions in the Q&A pod, and when we get to the discussion in part 2 after our lunch break, we will try to get to your questions and dovetail them into the discussion. And if you have comments, feel free to add those to the chat pod. As the speakers go on, your own experiences, and that can also help us with navigating our discussions later. So our next speaker is Jim Harmston. And Jim, if you would like to, well, actually, I think Mary is going to put your slides up. I'm going to introduce you. Jim Harmston is a former foundation contractor with over 65 years experience as a pile driver, crane operator, and caisson rig driller. And he specializes in soil nail walls, micropiles, sheeting and shoring, and vibrated beam slurry walls. Jim developed jack piles and other specialty systems for small structures, and he pioneered micropile technology in North Carolina. Jim developed the drill rig operating schools for the Association of Drill Shaft Contractors, or ADSC, and was recognized by ADSC into being elected into the ADSC Hall of Fame. I also know Jim from years past and his commitment to innovation, and his work with the ADSC Carolinas chapter has been just tremendous in continuing the learning experience for us, and for all of us in practice. So Jim, certainly appreciate all your efforts and your innovation ties. So Jim, with that, take it over.
Well, thanks for the introduction. This first slide here shows a picture of me when I'm about 4 years old, and my bio states that I've had 60-some years in there, but I didn't start then. But anyway, it's interesting. I had an interesting career, and I'm still involved in it. I love every minute of it, and nothing like it. How do you switch the slide now, Mary? Okay. This is a project we did down at in Charlotte. As a contractor, I never really had a brochure, but I'd stop by engineers and I'd say, tell them about some new equipment I saw or some can be purchased. And this one engineer said, well, we're going to have.
Jim, I'm really sorry. I just muted you by mistake. You'll need to unmute yourself if you can. I'm so sorry.
Okay.
Sorry. Thank you.
This stop at this engineer and he said, we're going to have a job for you. We're going to knock down this building here. Then you have to put some shoring alongside over here because we're going to have to take and dig a basement about 20 foot deep. for this new structure. And I said, why are you wrecking the building? And he said, well, we don't want to go upstairs and back downstairs. So I said, well, why don't we just hold the building up in the air and dig up underneath it? Of course, he said, are you crazy? No, not quite. I haven't been, analyzed like that, but no, it'll work. And we convinced him that we could go in there and put micropiles in the existing building while they had people in it. And this is a hospital. So we went in there and we drilled down these 4.5-inch micropiles down about 70 feet, then built that little frame on top and grabbed that column and dug the basement. Now you're going to ask, well, why is that old footing up there? Well, the contractor working for was drank a lot of coffee. Let me say that, okay? And he told the guy to get out there, the demolition guy, and get these footings off there. And the guy said, I can't get there for like 2 weeks. And he said, well, you're going to take them off in the air. And we went on, and that's what they did. So anyway, it really worked out good. I was really concerned. We had this thing supported, and I'm down there watching one day. We had this building monitored and this, that, and the other thing. And a guy backed into one of these piles with an unloader, and I just turned, oh my God, what's going to happen now? And nothing happened. So I was really quite thankful at that. Can you change the slide? Can you? There's a picture of, there's 2 more footings over here on the left you can't see. Okay, all right, change the slide. This, you probably have heard of vibrated beam slurry walls. They get quite controversial. Do they work? They work good. I'm going to say they work excellent up to 40, 50 feet, maybe even 60 feet. I would not put one in deeper than that. But how do they work? Maybe go to the next slide. You take and you have a set of fixed leads on a crane, and you take and you drive this beam in the ground, and the beam has nozzles on the bottom. And as you drive the beam, you pump slurry down there. And you drive down to a certain depth, and on that particular project, we drove down into the clay, the Cooper River Formation down there. It was about 40 feet down. And then as you extract the beam, you keep pumping the slurry, and then when it comes all the way out, then you just back up. We would back up about 30 inches and redrive the beam. Think about it like a sewing machine, okay? And it's a very simple process. Does it work? In most cases, it works very well if it's used in the right place. Change slide. Here's a picture of the wall after it was being excavated. The wall right there is about 4 to 5 inches wide. Change. I just put this picture in here just for interest. This is a tower crane base in Munich, Germany. I know we've worked on some tower crane bases here for some contractors, and they're worried about the thrust, the side thrust. This thing is in the air about 15 meters. And these are 48-inch drilled shafts, and there's no cross bracing on this thing. So somehow or another, they've got this thing figured out, and maybe we don't. Change slide. This is another picture of that vibrated beam slurry wall. This is a job in Mount Holly, a chemical plant. And this wall here was about 30 foot deep, and that's the Catawba River on the left-hand side. And then they built a new dam on top of it for a holding pond. Change. This is a simple 200-ton load test. We can set this load test up in no more than 4 hours from the time we drive the pile. Just using timber pile, notching timber pile. Very simple, but it really works. Change. This is a project up in North Carolina State, and this is a good example of this whole A-team project. This is NC State, and they're going to put this addition on this building over here where the rig is sitting. And we got the SAW report, and hey guys, we can't do this. Well, that's what the SAW report says. Well, I'm not so sure about that, but anyway, we can't do it. So I talked to the engineer, we wasn't getting any place. He already had the design. but he specified Raymond step taper piles. Well, if you know anything about them, first of all, Raymond now is out of business, okay? And there's stories about the step taper piles still being available. I'm not so sure about that. But that was the one problem. But the second problem was if you see the top of the pile driving leads, they're underneath the overhang of the building. If you drive step taper pile, you have to have at least twice as much leads as the length of the pile. It wouldn't fit. Pure and simple wouldn't fit. So we didn't bid the job, and then the contractors kept, well, what are we going to do? So anyway, we gave them a price on pipe pile in sections, 8 and 10 foot lengths of pipe pile. And we submitted that to the engineer, and he rejected it. So what do we do now? Well, thankfully, I had some guidance, and they said, write to the state property control and ask for a hearing. And which I did, and they said, sure, come on down. So we go down there with the engineer, the geotech, and anyway, the guy said, what's the problem? I said, well, we can't do the job the way it's specified. And he said, why not? So I explained it to him. He had some sketches and everything. He said, okay. He said, what do you recommend? I said, I recommend that we use 8 and 10 foot pipe sections and drive in the sections. And no question asked, he said, I suggest you go ahead and do that. And the engineer in his defense said, well, the soil report said you could use Raymond step taper pile. Well, the soil report was done like in about 1950. And its original building was on step taper pile. And he literally accepted that as well. That's what I'm going to use because that's what you used before. But he never realized that it wouldn't fit under his new structure. Change. This is an interesting project I thought you might like to see. I was working for Raymond. This is a McCormick place in Chicago. And Raymond was, if you knew anything about it, a very unique company, very creative. We're driving batter pile here. And when you took the hammer, when you loaded the pile under the hammer in the leads and took the hammer up to the top, the leads wanted to turn over backwards. Raymond said, no problem. They put 4 tons of counterweight in the bottom of the leads. No problem. But this was a pretty interesting project. We had a mile of sheet pile here, and we did it in one season. Change the sign. What they did is they found some ore boats up in Sheboygan, Wisconsin, and Raymond rented these boats. And we put this, I'm running this 3900 here, and they took the boats over to Inland Steel and loaded all the sheet pile on this boat and loaded all the H-beams on the other boat. Towed it back over, and we went to work. No work barges, no loading in this loading barges and unloading barges. We had all the material right here on the ship. We did this job in one season on the lake, and everybody else was figuring 2 to 3 seasons. But like I say, Raymond was a very creative company. Change. Here we had, see the Worley crane on this boat here. There's one of the rigs here driving some support piles with a template, and there's the other rig back there. Switch. This is a project down in Clemson. They had to put a basement in this building, but they had this existing column. What are we going to do with it? Well, we did this very similar to the hospital job. We put these micropiles down and made a frame. And then after they dug it out, they just dug it out and extended the existing footing down to the new elevation. Change. This is a project we got involved in up at Billy Graham Training Center up in Asheville. We got called in to put a soil nail wall in there or something, okay, to put this roadway in there. Well, just looking through one of the periodicals one day, I saw this product from Eli Lilly called BioBarrier. And I wrote to him, and it was a piece of, if you can remember that candy you had as a kid on a piece of paper with all the little dots on it, that's what it looked like. And what it was a root repellent. And you put it in here, you know, behind the waterproofing, and supposedly, as they tested it, it would take and repel the roots rather than push the wall over. Well, it was pretty good. As a matter of fact, FHWA came to the office one day and said, hey, would you mind if we consider this on our 421 project from Winston-Salem about the Boone? No, go ahead. You know, actually, even gave them the drawings and everything else to take back. And it worked very well. I'm not sure if they still make it or not, because it's probably about 15 years old. But it was called BioBarrier, and it came from Eli Lilly. And I thought it'd be great on the sidewalks and stuff like that, where it would take a repel tree roots rather than buckle the sidewalk. Anyway, change the slide. This is a project over in Pine Knoll Shores on the East Coast. They wanted to build these retreat center barracks for the kids in the summertime, but you couldn't cut down any trees. You couldn't cut down, you know, any roadway trees or widen the roadways, anything like this, you know. And so only 2 contractors bid at us and another guy, but he specified they had to cut down trees because he was going to walk a 30B with 70 foot of boom down this roadway to get these different paths. Well, you know what, guys? Let's take the cherry picker down there and drive them with a 9B3 hammer. And okay, we get the job. I go down there one day, and a couple of places were pretty good. Access wasn't really a major problem. We got to this one, and the operator said, "How are we going to get up there?" I said, "You're going to drive the cherry picker up the stairs." The stairways were about 10 foot wide out of railroad ties. And he said, "What?" And I said, "Go on, just drive it up there." And he did, and it worked fine. But sometimes you got to do things. Anyway, change the slide. This is a picture of a batter pile load test. Why a batter pile? Because the engineer said so. That's the only reason. Can you test a batter pile? Yeah, we can do that. Okay, I want to check it, so we did. So anyway, change the slide. That the last one?
I think that's the last one.
Excellent.
Oh, okay. All right.
Jim, you have a lot of stories. And, you know, I think that, you know, if I had to sum up what you shared here, it's really, you know, a mosaic of the experience that you bring and you can bring, and just the practical considerations, constructability considerations that, you know, if we, you know, tapped into your experience and your insights, you know, that will go a long way in solving a lot of the problems, or, you know, preventing some of those problems. Is that a fair statement?
Yeah, I've done a lot of, as you want to say, consulting is the right word, but I don't even consider consulting. You know, I've visited jobs with engineers beforehand. We did a job down in Charlotte. I don't remember the name of the building, but anyway, the building was settling. Okay, and this is like maybe about an 8-story building, and they're moving furniture in there, and they couldn't even put the chairs down. The chairs are sliding across the floor, and the owner necessarily, or not necessarily, the owner had a fit. And an engineer friend of mine called me up and he says, "Can you meet me at Charlotte at 1 o'clock in the morning?" I said, "What?" He said, "Meet me in Charlotte at 1 o'clock in the morning." So I go down there and meet him. He said, "This building is settling, okay?" And AT&T had like a 20-year lease on this thing. And he said, they told him they're moving out in the morning and stuff like this. He said, "What can you do to fix it?" Well, the building was on drill shafts. Well, unfortunately, they found one of the drill shafts on a boulder. We went in there with one of our small rigs, and we drilled down around all of the original caisson, and we drilled down about 60 feet, and we grouted some bar in there up to floor level, and then we extended the bar up to the top of the first floor. And then they poured a foam rounder, and then we through bolted the new shaft through the original shaft, and then stopped the settlement of the building. And even when we jacked it about a ½ inch, and it was too risky. So anyway, but we've done a lot of stuff like that.
Yeah.
You know, like I say, 1 o'clock in the morning.
Great. Well, Thank you very much, Jim. Yeah, I think this is great information that we can take to the discussion in after lunch too. Thank you very much, Jim.
You're welcome. Thank you.
So our next speaker is Brian McGlynn, and Brian is a senior estimating engineer for Menard. He's earned his Bachelor of Science from the University of Pittsburgh in civil engineering and civil and environmental engineering. He earned his Master's of Engineering in Geotechnical Engineering from Texas A&M University. Jim has worked with Menard since 2013, beginning in the field and now working with the design, operations, and estimating team at Menard. Brian is a licensed professional engineer in the state of Texas. Brian, thanks for being here, and you have the floor, sir.
All right, thank you very much. I hope everyone can see my screen and hear me fine.
Yep,
we're very excited to be here. So we're always excited to present some of our experiences as a ground improvement contractor, and we feel very fortunate to present to such a large audience. I guess before I start talking about our project, allow me to introduce Menard. So we work nationwide as 3 separate brands, Menard across most of the country, also including Feral Design Build and Earth Tech in California and Florida, respectively. I would say 90% of the work that we do is as a performance-based design build contractor, both in public and private work. The case history that I'll present today will be part of that 10% where we're actually functioning as a quote unquote dumb contractor, installing wick drains at the Port of Long Beach Middle Harbor development. This is one of those projects, that I'd once read the phrase, the second marriage is a triumph of hope over experience. And I think being the low bid ground improvement contractor on a job with limited soils information is another example of triumph of hope over experience. So before I go too far into our experiences at the Port of Long Beach, I want to give you a little bit of information about what the project entailed. So this was a project that the Port of Long Beach had undertaken beginning, I want to say in like 2010 or 2011. It was a 10+ year redevelopment of 2 of the piers currently existing out there, and turning it into 1 mega pier, or the Long Beach Container Terminal. Upon completion, it'll service over 3.3 million 20-foot equivalent containers per year. It was also created one of the cleanest and greenest seaports operating in the world today. So in all, it was a very cool project to be a part of, one of those critical infrastructure projects that, you get to work on maybe a couple times in a lifetime. So I was excited to be able to experience it. And I will say, I don't think it was our wick drains that caused the backup at the Port of Long Beach the past couple of years, but who knows, right? And here's a picture kind of illustrating the change that the pier had undergone. So in this case, we'll be talking about this area that you can kind of see from 2020 that's still fill. So before I get into the project, I think Steve did a pretty good job of talking about wick drains in his presentation, but I'll just give a quick recap as to how wick drains work. So wick drains are typically used in fine grained soils, so typically clays or silty material. And what they do is they shorten the drainage path that the excess pore water pressure has to travel, accelerating the consolidation of the material. Wick drains are typically installed anywhere on, I would say typically we see 3 to 7 foot spacing. The depths can go, really as deep as the equipment can support. With our conventional equipment, we kind of see it maxed out around 150 feet. But in general, you're just targeting those clays, potentially soft clays or silt layers that could cause settlement issues for the project. So for this project, the contract, so we were involved as a subcontractor. The general contract, as it related to our work, kind of had 4 key areas. So there is demolition of some existing port infrastructure that was going to occur before we got there. This was important to us because our equipment and material is designed to penetrate soft soils, not necessarily concrete rubble. And so it was clear what was being demolished as well as where they're going to place this demolished material. Fortunately for us, the engineer in the port did not expect us to penetrate into soft soils in these areas that they were depositing this material. The next step for the general contractor involved dredging, infilling this slip with material from a number of different areas called out in the contract plans. And this was ultimately the material that would require wick drains. This is where we came into the picture. We were installing wick drains, targeted about 75 feet deep. And then what would follow after that was a surcharge program in the area, I want to say it was about 20 to 25 feet surcharge. A settlement monitoring period would begin after the surcharge was placed. Once the settlement had occurred, the surcharge would be removed, the area would be rough graded, and then it would be handed over to a separate contract where the final port infrastructure, the container yard, the paving, the cranes would all be installed. So for us, the soil conditions, when I say limited geotech scope, maybe it's a little bit unfair. We did have 4 borings in the area. In general, the depth of the soil borings range anywhere from 70 to 90 feet. Material or information that was provided with these borings that we wish we would be able to receive on all of our projects included, what sort of hammer was used, what the hammer efficiency was, the coordinates of where the borings were performed, as well as the elevations of the borings. And this was where we kind of ran into our first challenge. So for the elevations, for the one boring, it's minus 52 feet with about 50 feet of water above it. The second boring, I think is about minus 65, minus 60 feet, and then minus 45 feet. So at the time of the bid for us, the information we had available for the slip fill area was mostly where the mud line was. It was pretty clear in looking at the borings that, yeah, there was soft material there, but everything above the mud line was to be determined. And so, here we were, this was September 2017, that this was essentially the information that we had. We knew there was a dense native sand beginning around minus 65. We knew where the mud line was. And then we knew the material that was going to be placed was going to be pumped in, multiple different sources. We had reviewed and read the specifications for the dredging, understood that debris and large cobbles would be removed from the area. So okay, we can expect pretty reasonably that this shouldn't present any penetration issues. And then the last, say, 15 feet or so was going to be mechanically placed. So there is previous wick drain contracts that had been undergone at the Port of Long Beach. There's plenty of surcharge material. So some of that surcharge was going to become the new fill. Some of it was going to work as additional surcharge under this contract. But this material, we knew would have, big pieces of earth moving equipment on it. It may be, while not compacted in an engineered way, may be compacted in such a way that it could present challenges for wick drain installation. And then per the spec, the wicks would be installed anywhere from a working elevation of plus 10 to plus 15 at the site. So as I mentioned a minute ago, our target wick length, about 75 feet, up to 80 feet, depending on the working elevation. And, one of the considerations that we had was that, well, this top 25 feet or this top 20 feet may prove a little difficult. So we had actually carried a pre-augering for that material as incidental to the wick drain pricing. So then here we are, December 2018. So over a year has passed since we had initially bid. And, this was the before time of rapid inflation. So we'd actually, were able to hold our pricing steady throughout this period. But this is essentially the total wick drain area as well as where it had been infilled to date. So we were still about a month or two out from mobilization for the wick installation. We'd be starting in this G1 area. And so we mobilized at the end of January, beginning of February. They went out and did CPTs in this G1 area. And you can see on the plot, in general, the scope was somewhat limited, the different elevations. And then these are the results we got. In general, very shallow refusals when considering that the wick drains would have to be installed 75 to 80 feet deep, continuing essentially through all the CPTs taken in this area. So at this stage, we're just about to start the wick drain installation. And so, the question kind of arises, well, like, would we consider this to be a change of conditions? Obviously, with wick drains, we're expecting to be installed through very soft material. The CPT profiles showed that some of this material was much sandier than what you would typically expect for a wick drain installation. But ultimately, we were relying on the specifications as written. And within the specification, there was a minimum equipment push force, which is very common on public bids to see. And it was 40,000 pounds. So we figured, okay, we have the equipment that can meet or exceed that. We understand that while the soil conditions weren't necessarily known at the time of the wick drain design, that this was probably considered, and our wick equipment would be fine. So it's not a change of conditions, it's just what the conditions are. The spec also required a minimum of 2 reattempts if the wick didn't cut to depth. And at the start of the project, that depth was, within plus or minus 5 feet of the termination criteria. So here's a picture of our machine. So we're working off of a 80 ton excavator, so 160,000 pounds, push force of almost 50,000 pounds. The issue we ran into, though, particularly with this 5 foot requirement, was that we were performing a number of reattempts. So this was a case where we were meeting the spirit of the spec, but ultimately we weren't happy because we were essentially getting paid for 3 wick drains for every wick drain that we needed to install, but it was just really tying up our people, tying up the schedule. And so ultimately what this led to was, as we just kind of slogged our way across the site, the final area, they had decided that, okay, well, how this worked out with the earthwork contractor, they were going to run out of space to work. So they said, okay, we'll have them place the surcharge in the final area to keep them busy while you finish out working in this second to last area. That way, so they don't have to demobilize and remobilize. So we went from having a working elevation of plus 10, plus 15 to now having to work from plus 34, which this was clearly a change of conditions for us. And ultimately what it led to was, 100-foot pre-drilling being performed from the top of the surcharge pile. This was work that we actually did not perform. The general contractor had subcontracted a dedicated pre-drilling company to do. And our wick drain production probably went from, I don't know, like 250, 300 a day to 50 a day. We could only install as many holes as the pre-drilling could open up for us. And we had to work in such a way that any sort of aging effects of the pre-drilled hole could result in shallow refusal again. So it was just a slog to really get through. ultimately, the takeaways on this was, we had a wick drain quantity overrun of about 25%. The final contract value for us as the wick drain installer, almost doubled. And, at the start, we were probably only about, I would say less than 2% of the overall contract value. And this doesn't even include that the final pre-drilling costs. I think that in itself either met or exceeded the cost of the wick drain installation just to work that final area. This project had multiple delays on our end where we would be working, we'd run out of areas, we'd be told to, go on standby for a couple of weeks while they tried to figure out what sort of approach would we want to take in different areas. Ultimately, in those different areas, there wasn't much additional geotech exploration nor settlement monitoring information taken into account when coming up with potential approaches. So ultimately, we'd have to leave the site for a couple of weeks and then come back and just essentially, keep trying with our approaches that we were attempting. It also affected us not just on this project, but we had some of our best operators on the site. It's a very challenging site, and it occupied their time for almost a full calendar year. And it had run-on effects where we had planned on using some of this equipment at different project sites. We had planned on using some of these people at different project sites, but we just could not free them up, just really due to the geotechnical conditions that we ran into at the site. And so this is the picture I'll end it on. So this is one of our mandrels that broke off in a hole from the top of the surcharge pile. And it kind of illustrates the additional challenges that you run into that kind of compound upon themselves when you don't have great geotechnical information. So now instead of us just having to cut this mandrel maybe down a couple feet from existing grade, it's now sticking about 25 feet up from final grade for the container terminal. So this one piece of steel probably resulted in 5 RFIs as to, 2 or 3 coordination meetings as to how we're going to handle, removing this in light of all the surcharging and final grading scopes of work that had to follow the wick drains. So I thank you for your time. Are there any questions?
Yeah, absolutely. Great presentation, Brian. And, just it does illustrate, the impacts that are on you, when we don't have the information that you need. I have one question on, you had mentioned having boring information up front with energies, with locations that were accurate, which is, a good thing. In your, comparison with the cone penetration test and the data that you had, what did you see? Obviously, 2 different tests, but were there, details within the materials that you were seeing with the CPT results that, just weren't there early on?
Yeah, and so I think that was part of the challenge. So essentially, where the depths of the CPTs all hit refusal was still about 30 to 35 feet above where the start of the borings and that information. Okay. Yeah, gotcha. Yeah. So all the borings were taken from the water into the mud line, and the CPTs were all performed from the surface. Gotcha. After we had already started wick drain installation. And so, yeah, it was a challenge because we didn't know what we were going to encounter. And we also didn't know what was below that refusal. It very much could have made sense that, the material below it could have been very soft clays or silts that would require wick drains. And so it wasn't enough for us to just say, oh, look at this, you hit refusal 30, 35 feet down. Let's just install the wicks to 30, 35 feet.
Right. Very good. Thank you very much, Brian.
Thank you.
So just a reminder that we do have the poll still open. It's not going to be open for very much longer. You've got about 10 minutes or so before we close that. So if you haven't completed the poll questions, please do that, and that's going to help us sort of frame some of the discussion that we're going to have after our break. But we do have one more presentation before that. Also, just wanted to remind you, if you have questions that you want our contractors to, this is an opportunity to talk directly to our contractors. So if you have questions about the impacts that some of these, what we do up front before we get to construction, and how we can help minimize these problems that you're seeing, just like what Brian presented here. Our next presenter is Rick Deschamps. Rick is both a PE and a PhD. He is the Vice President of the Vice President of Engineering at Nicholson Construction Company. He is a licensed professional engineer in several states and has over 35 years experience in the industry, from consulting, academia, and construction. He currently oversees Nicholson's design group in the development of competitive design build systems for geoconstruction projects throughout the United States. Rick, you have the floor, sir. Oh, you're on mute. Down at the bottom left, you should see, if you scroll over it with your mouse, you should see it come up. So if you point your mouse.
All right, we good
Yep,
to go?
you got it.
You can see my screen okay?
Yes, we can.
All right, thanks, everybody. I appreciate the opportunity. As Ben said, a little bit different about my background. I've been in construction for about 18 years now, but with Nicholson. But prior to that, I was working on the design side for a couple of good companies, and also was on the faculty at Purdue teaching. So I've kind of seen our industry from both sides, and it gives me, I guess, a different perspective. But the project I'm going to talk about here today is a repair of I-65 bridge over Wildcat Creek. This project took place in 2015 and 16. The picture on the left-hand side is really the bridges we're talking about, and the project was an expansion of the highway. And so the goal here was to add to this bridge and put a couple more lanes in between. And if you look at the picture on the right-hand side, this is pier number 3 of the existing northbound lane. And what had happened during construction is that pier settled suddenly about 10 inches and tilted about 7 inches, which caused closing of the highway, it was not a good thing. And with that, I'll tell the story. So here's the site in Indiana. It's just east of Lafayette, Indiana. And it was a design build contract for this length of the highway. It was won by Walsh Construction, and that's who we had worked for. And then the location of Wildcat Creek here is on the north side, and that's the bridge that we'll talk about. A little bit of a closer view again, looking from the sky from an aerial view. You can see the existing bridge, and the main idea here is to put 2 more lanes in between those existing highway lanes. Now, if you know Indiana, and especially the northern part, it's extremely flat, big glacial till plain, but the river valley was in fact incised about 75 feet below grade, and you can see the floodplain down below. And at the time, there were 4 contract borings, both abutments and lower on the floodplain and on one of the slopes, and they all showed pretty much the same thing, and that was primarily glacial till over a dense glacial outwash. And looking at them in more detail, there was a layer within the glacial till that was clayier than the remaining till, more sandy below that zone. This is a elevation view of the original bridge. You can see on the abutments that there's driven piles, but what's unique here is that the original bridge was on shallow foundations. And so piers 2, 3, 4, and 5 were founded on shallow foundations in the structure. And if you look at the planned elevation view of the new structure, you can see right away that it's been planned to be constructed on driven piles. So the new portions of the bridge would be on driven piles. H piles were shown on the schematic drawings for the design build contract, and H piles were recommended by the geotechnical in the geotechnical report. So this is kind of a view of what's the work that's going to be done. You've got your existing piers in gray on both sides that are supporting the existing lanes. And the idea to come in here would be to drive piles in between those two piers, put a cap on top of those piles that would connect to the existing piers, and then build up those piers to be able to support the two new lanes on the top. This is kind of a view of the cofferdams. Those for piers 3 and 4, they would be in the river itself, and so cofferdams were necessary to drive the piles into those two locations. You can see for pier 2 here, the formwork is already in place to put the cap beam on the piles. So here's the kind of a timeline. So those cofferdams were installed in order to drive the piles at piers 3 and 4. And then the piles were driven at pier 3 at the end of August, end of July and beginning of August over a period of about 5 days. And then 3 days afterward, there was a sudden settlement of the pier, and it settled 10 inches and tilted 7-inch northward. And the bridge had to be shut down, and so poo-poo hit the fan. The discussions began, was the pier safe? Could something be done to temporarily open up the bridge? And you can imagine it was pretty significant political pressure to get things moving. Come back to the same photo and show you that you can kind of see here in this view where the pier was settled, and you can see the dip in the roadway that took place there. So at that time, the specialty contractors, geotechnical contractors were brought in to visit the site, take a look around, and some of the things that we saw, you can see on the left picture, you can see where the cofferdam is in place. And you can see on the right where the cofferdam is also in place. And there's also, you can see the piles, if you look closely, that have already been driven. And one of the important observations here is the level of water inside of the cofferdam relative to the river level. It was much higher and actually overflowing the lowest sheet pile segment in that cofferdam. So, as I said, the contractors were involved. What were some of the ideas for stabilizing the pier? Remember that schedule is critical, and all options would be vetted with Indiana DOT and FHWA. So what were some of the things to consider from the contractor standpoint? Well, we wanted to identify the cause of failure before we design the repair. Wanted to get our hands on all the information we could get, including the historical data. And the concerns was, it's settled, but is it at risk of settling even more? Could the work that we're doing actually cause a problem? Could it cause a problem for any other piers for the structures? Because we wanted to do no harm. But it was pretty evident early on that there was an artesian condition here, and that's what would have caused the elevated waters inside of the cofferdams. And that was reinforced when looking at the most recent and historical borings. These were the borings that came out with the contract. Some of the notes, artesian water noted flowing up adjacent to the existing piers. So this is even before drilling that you could see water coming up adjacent piers that had already been constructed. And then there was lots of notes about heaving sands within the augers and having to use bentonite and the inability to get good quality samples because of the heaving sands at various depths. This was reinforced with the historical borings. When you went and looked back at the data that was available, there were indications that the heaving sands made it impossible to get samples at various depths, and that the actual SPTN values that were recorded were probably not representative of the in situ conditions. So even though Indiana is really flat, again, this valley is 75 feet down. And so all the infiltration that takes place coming down can recharge this zone. Maybe this outwash daylighted someplace. It would be an infill area where that it could be charged with water. But this this clay till layer here ended up being an aquiclude that really created part of the issues that we'll discuss here. And if you looked at the piezometric head right below that aquiclude, it was something like 15 feet above the floodplain. And we expected that if you went all the way down the glacial outwash, it would probably be even higher because you wouldn't have the head loss through the remainder of that till. The cones that went down through here to kind of gauge that really refused in that glacial outwash. So I guess the hypothesis then was that the driven piles broke through this layer and opened up an avenue for flow on the outside. And that avenue for flow allowed the artesian pressure to carry materials. And so I've got a little video here that I'm going to show to kind of give you a feel for the importance of I guess, piping and erosion.
This is a video showing piping underneath a sheet pile dam in a model in the lab. Here we have the dam. It's the black line in the center. We're going to add water to the right side. It will flow through the soil on the bottom and come out the left side. And if the head difference gets too big, we'll see a failure. Of course, I wouldn't be showing you this if the head difference wasn't going to get too big.
Ben, can I confirm?
So we continue to add water. The soil's pretty dry, so you can see the wetting front moving down. We'll take a
Didn't
jump
hear you.
and it's
Did I
going to move
confirm
around
you're
where
hearing
that hand
sound
is
okay?
showing you.
Yes, we are.
Yeah,
Thanks.
this is going way too slowly. So let's pick up the pace. Here we go. Alrighty, so there's the wetting front moving around. And some people in the background moving around. So we'll see the wetting front almost complete, at which point so we'll see some heaves start to occur just to the left of the tip of the sheet pile. Here's a little more. There's a heave starting to take place. It's going to blow any second now. I think we're going to see it go. And here it comes. That's the way piping failures often are. Very rapid. Very, very rapid failure. That is to say, once it starts, it's almost nothing you can do to stop it, and you're going to have a disaster.
Okay, so I acknowledge that the piping failure that we showed in the video is related to dams, but the important point here is to understand that with enough of a gradient and granular materials, you're going to move these materials, and so the erosion could take place. And so essentially what occurred was that you were carrying sands from below that dense clay layer, or from the sandier till along the piles that were driven and the broken ground around the piles, and carried that to the surface. And we learned from post settlement CPTs and SPTs that there was a very loose zone below this layer. So in concept, this dense layer here probably bridged for a while until this cavity got to be so big that it actually collapsed, and that's why the settlement was so abrupt. And this is the borings that were taking place in CPTs after the fact. And the important things to note here is that right below that layer, you're getting blow counts that are 0 blow counts or very low blow counts. And similarly in the cone penetration test, the tip resistance has dropped off dramatically and indicated loose sands. And also, if you look at the pore water pressures in the water pressure measurements, that the line was greater than hydrostatic. So now the idea is we understand the problem, so how are we going to solve it, and what can we do to fix it? So goals being, we don't want to cause any additional settlement as part of the fix. Whatever we do has got to be able to address these artesian conditions so that ultimately we can carry the load. The approach that we chose to present was the use of micropiles. Micropiles are fairly versatile in terms of being able to get into different areas, and especially below the bridge deck that was in place. And we also, an important part of that was going to be able to drill with grout. And I'll explain the details of that, but by drilling with grout, we could offset the water pressure from the artesian water conditions so that we could safely get the piles in place. And the other approach that we're going to include in this was to do some compaction grouting. So get underneath the slab or the existing spread footing and do some compaction grouting so to support it while we're getting the piles in place to ultimately carry the load. When I say micro piles, there's many ways to install micro piles. The approach that we used was external flush. It's called external flush because you got a single tube that drills down. The fluid that you're using is flushing through is the fluid that's going to carry the spoils back to the surface. Some micro piles are duplex where you've got a casing on the outside. In this case, we didn't want to do that because we needed to have be able to drill with grout. And these are some of the bits that were being used on the project. This is a regular roller bit and this is a Ken claw bit. I think a concept here that I'd like to share, I guess, when you're drilling micropiles below the surface is it's always important to have a head of water in your annular space on the outside that's higher than the head of water in the ground, higher than the groundwater level. And the reason to have that is your seepage is tending to go from the annulus out. And so you got seepage stresses that are actually stabilizing the hole. So that keeps the hole from wanting to collapse or the ground from wanting to collapse around your tooling. And in an area like here where you had artesian pressures, if the water levels in the ground is higher than the water levels in the annular space, then what happens is that the seepage stresses are going into the annular space, and this causes collapse of the ground and loosening of the ground. So the reason to drill with grout is because the grout is denser. So when you start thinking about the actual head, you've got the head of grout times the unit weight of the grout, balancing the head of water times the unit weight of water, and the unit weight of the grout's about 90% higher, so 190% of the weight of the water, and that's where the balance comes in place to be able to balance the water pressures. Jim talked about micropiles and the flexibility of micropiles. This is a famous photograph from Nicholson, but essentially these small rakes can get you about any place.
Rick.
Pardon me? Sorry. You can get these small rakes can get just about every place. And so we're showing here, there was an interesting project at Exton Mall over near Philadelphia many years ago where there was a second story put on the mall. And that construction happened at night so that the stores can stay open during the day. And so this is the picture of a rig getting into Victoria's Secrets. And rumor has it more than one of these guys came out of there wearing women's underwear. So this is the approach that was implemented. So essentially there was a surface casing that was put in place. It didn't go all the way through to break through that clay layer. It was grouted in place, and then a pipe was driven down through to complete that so that the injection of the compaction grout could take place. Once that was sealed and grouted, then the micropile was drilled back through that and installed. And then there was a bar put in the top to be able to carry the tension loads. And then this was completed across both sides of the pier. So there was 6 piles on each side of the pier. And then finally, there was a pile cap that was put on top that was tied to the pier, and I'll show some pictures of that here in a second. So there was a test program that needed to be done. 2 verification tests were done because it was really logistically difficult to try to do proof testing, which was desired for the piles that were in place. So 2 verification tests were done, and those were done, emulated the actual production work. So there's a surface casing here. This is the drill pipe that's going to go down and ultimately be the pile that's in place when it's grouted. This is the compaction grout that would be pumped in there prior to installing the pile. And then you kind of get an idea of the bar being lowered down, what that would look like. Load test, here, a little plug for Purdue. You can see the Purdue P here nearby in West Lafayette. And then I guess just a nighttime view of the load test being performed. This is the pile load test. So the design load was 208 kips. It was tested in tension for convenience, so there wasn't a need to put reaction piles in place. And the ultimate load was about 2.5 times, a little over 2.5 times the design load. If you'd have tested in compression, it would have been much higher than that. some production photos. You can see again the rig coming underneath, being able to drill and install underneath the bridge deck, installing the micropiles. You can see the micropile casing in the foreground. And then just another view of micropiles being installed. You can see the roughened surface there where the connections are going to be made to the concrete. Here's where the pile cap and connections are being done, drilled holes right through the existing pier so that bars could go through to put the cage together. You can see the cage here being fabbed prior to pouring the concrete. In fact, the micropiles were installed for the other piers as well because there was similar concerns for the driving of piles to cause a similar problem. So micropiles were used for the remaining piles for the project. This is a proof test for the pier 4 and 5, essentially using a couple of the piles as reactions. You can see the bars coming in here because they're going to be loaded in tension in order to be able to put compression load on the pile for the test pile. So I'll provide a summary, I guess, of what I consider to be the facts, and that is that artesian conditions were identified in the contract borings and in the historical borings. Driven H-piles were shown on the conceptual drawings in the design build package, where they're recommended in geotechnical report and were installed by the design build contractor. Penetration of the clay till by the H-piles led to upward artesian flow that removed sand, and the loss of sand below the clay till led to abrupt settlement of the Pier 3 spread footing. And I'm not sure, Ben or Mary, how to do this, but a couple of questions we were going to pose to the audience, and this is the first one. And that is, who had primary responsibility to recognize the risk of driving piles in the artesian conditions on I-65, on the I-65 bridge project? So what's the direction for our audience to do with that?
Yeah, so I think Mary might be populating a poll question for the audience at large, but I think this is a good sort of teaser for our next session here with our panelists and speakers. What are your thoughts on who had primary responsibility?
I just launched the poll so people can answer the question if you want to give people a minute to think about it.
Okay, very good.
There's just 2 questions to this poll.
Yeah, so I mean, always sort of after the fact is different than in the heat of things here. But yeah, this is a real question that we deal with when making decisions during design and constructability, and what we see, what we don't see, what we pay attention to. Who was primarily responsible for recognizing the risk. So this event did not happen yet. It's there's a probability, and obviously we saw the consequence of that. But yeah, thoughts from our panelists and speakers.
At this point, most of the people have answered. So if you want to
Okay, yeah,
kind of dive into it, you can probably go ahead.
Remind me, what type of contract was this?
Design build.
Okay.
Ben, we've got a couple of questions in the chat. The first one was already resolved, that it was a design build project. But second question is, why does a drilled micropile mitigate artesian conditions while a driven pile does not?
And I tried to explain that, but obviously didn't do a very good job. So the micropile is being drilled with grout. And so the grout is denser than the water. And so the annular space between the ground and the casing of the pile is filled with this heavier material, this grout. And so the pressure, because of the height of grout times its unit weight, offsets the height of water, considering the artesian, times its unit weight. So if the artesian was too high, it wouldn't have worked. But in this case, the artesian wasn't so high that the head of grout was sufficient to balance that pressure.
Cool, thank you. Another question from the chat. Did we hear that the upward flow was observed during the design exploration drilling? And was this occurring before the piles were driven?
Yes. So the borings that were included as part of the bid package identified artesian conditions and identified the fact that the sampling was being affected by the heaving ground into the augers.
Good. And Mary, do we have the poll results to display?
Yes, I will I'm going to end the poll now. So hopefully everyone who wants to answer has gotten a chance. And then I will share the results. Are they visible? This is my first
Yes.
time doing a public poll.
Yes.
Okay.
Yeah, so it looks like 11% said the owner had primary responsibility for identifying this risk. 79% are saying that the geotechnical engineer was responsible. 1% the general contractor, and 9% the pile driving contractor. So, thoughts from the panel on this? Does this sync with your thoughts? Both owners and contractors. I mean, obviously you have different perspectives on where fingers point, on something like this. But yeah, I mean, is this reasonable? What you're seeing, the majority saying that geotechnical engineer was responsible.
So this is Steve Saye with Kiewit. From my design build experience, I think it highlights the fact that these things regarding groundwater, things regarding dewatering, they're often some of the hardest parts of the design build projects. And I understand here that there was a note on the plans, but you would really need to have an understanding of piezometers showing the head. I'd ask the question, is the pre-bid geotechnical information, did it clearly identify that artesian water pressures were a risk, or was it just a note on a boring log?
Rick, do you know?
I can't say for sure, Steve. I concur with everything you're saying so far. I can't say for sure, but I would suspect strongly that it was a note on a boring log.
So if we look at this, but where you have problems, I mean, most information, the dewatering contractor is the guy at the bottom of the totem pole, in that he has some very important things to do. But much of the time, the information that's available pre-bid is non-existent. I mean, sometimes you're lucky to even have a groundwater level. I would concur that I think that the design build contractor and his or her subs, clearly have a problem to resolve through there. But I think that a clear understanding of the water levels obviously was not prepared prior to construction.
I guess I would comment here also that the pile driving contractor, I'm a contractor, so I'm biased. We don't drive piles, so I can separate myself from that. But you know, they're going to be a low bid contract that probably have been told to drive certain, you know, certain size piles for certain depths, and probably have not been privy to any of, you know, some of this stuff. So it'd be difficult, I guess, for them ultimately to be responsible. But it's an opinion poll, so that's what it is.
Very good. Mary and Rick, do you want to display your second question?
I think that
Is it
she
showing?
Oh, you
did.
had,
Yeah, so it's on there. So
It's
which
on there.
I'm really happy to see that that people believe that the head should have been measured and provided,
okay,
knowing
yeah.
that they're Artesian.
And
Very
someone asked the question, how would a geotechnical engineer measure such a thing? Does anybody want to?
Yeah, you'd have a standpipe, so it'd be like a basometer, but it would be sealed, and it would have to be a standpipe high enough. And so I've been on projects before where you thought it was going to be 5 foot high and the water's still rolling over the top, and it's only rolling over a little bit. So you think, well, it's not going to be much higher. And then you put another piece of standpipe in the top and it goes up another 10 feet. So don't let flow rate be mistaken for pressure. There can be high pressure and very low flow rates. But yeah, it's a standpipe that keeps on going up until there's no more additional flow.
And we've seen instances where you'd grout a piezometer into the granular formation and then seal everything up above it and measure the pressure.
Measure pressure directly, right?
So there were two comments in the chat, and just want to make sure that we see those. Does this all go back to construction requirements to address a predicted potential scour risk, and has scour analysis been updated? Not quite understanding that question. But there was another question on, did the piles plug during driving to give any, I'm not sure exactly where one was headed with that, if, as far as a telltale maybe of conditions. Welcome back, everyone, from the break. Your break was good. This is the second half of our session, or our super summer session number one, stepping into the contractor's boots session. And we're going to get into discussions, and just wanted to introduce myself first. My name is Ben Rivers. I'm a geotechnical engineer with the Federal Highway Administration's Resource Center, and I will be moderating this session today. Before we get into the meat of things, do want to mention a few things. Number one, just reiterate a couple of things. Number one, from the FHWA perspective, this presentation and these sessions do not have any force of law or effective law, and aren't meant to bind the public in any way. This is information. We're going to be having a discussion here. And the other point I want to make here is that trademarks and the like, manufacturers' names are, if you happen to see them, they're informational. The U.S. government does not endorse any products or manufacturers. So, that's not the intention if they pop up in any of these sessions. So the other part, I don't know if I have a slide talking about this, but I do want to reiterate that we are having discussions here, and we're all individuals with different opinions, and that's fantastic, because that's why we're talking. So during these discussions, those opinions obviously reflect those of the individuals, not necessarily of the U.S. government or FHWA or our contractors helping us do the work here. So these are individual opinions. Yeah, so I mentioned who I was, Ben Rivers with Federal Highway Administration. I am joined in moderating this session by Derek Dassenbrock, also with the Resource Center Federal Highway Administration. He's a geotech, and Mary Nodine, who is our contractor for this with GEI, helping us moderate this session and actually pull all of these sessions together. This morning we heard from 4 guest speakers. I think there was great insight into some of the issues that we have, some things that we really want to lead into this discussion part. Steve Saye with Kiewit, he is a geotechnical engineer, has been there for over 40 years. He has 40 years of experience, been with Kiewit for the last 16, and focused primarily on design build and EPC, or engineering, procurement, construction type projects in the US. We also have Jim Harmston, who is a retired specialty contractor from North Carolina with over 65 years experience, and a real champion in innovation and sharing knowledge through ADSC. He's been instrumental in the Carolinas chapter in professional development. We also have Brian McGlynn from Menard. Brian has he's been working with Menard since 2013 and has experience in the field and also in estimating. That's his current role. Very knowledgeable in the ground improvement arena. And we also have Rick Deschamps, who is the Vice President of Engineering for Nicholson Construction, has over 35 years experience in industry through consulting, academia, and construction. So those are our guest speakers. We also have 4 panelists, peer panelists, who are going to represent the voice of the owner. Representatives in different backgrounds. We have Peter Davich, who has worked with Minnesota DOT for the past 18 years. And most recently, he's been working in the capacity of design build program manager. Before that, he graduated from the University of Minnesota and has a master's in geomechanics and has worked with the DOT, the Minnesota DOT Foundation and Research outfit before going into the design build arena. We have Sarah McInnes. She has joined us. Great. Sarah is Senior Assistant Construction Engineer with Pennsylvania DOT. She works in the District 6 area around Philadelphia and the 4 surrounding counties. Prior to her role, she spent 25 years in the Geotechnical unit and 13 of those years as the district geotechnical engineer. We have Kevin White. Kevin White is joining us from Arkansas. Kevin has a background in construction with over 25 years experience. His current role, though, is the division head for right-of-way, the right-of-way division in Arkansas DOT. But he brings a wealth of knowledge in the construction area and alternative project delivery, and was a project manager for the first CMGC construction project for Arkansas DOT. He's a graduate from the University of Arkansas at Fayetteville with a Bachelor's of Science in Civil Engineering and a Master's of Science in Transportation Engineering, and is a registered professional engineer in Arkansas. So welcome, Kevin, welcome, Sarah, welcome, Peter. And our final panelist here is Dustin Robbins. Dustin comes to us from Federal Lands, FHWA office in Central Federal Lands in the Denver area. Dustin spent 7 years in the consulting area in geotechnical engineering and project manager before joining FHWA, Central Federal Lands. And at FHWA, he spent 3 of those, his first years as a geotechnical engineer. In fact, was part of our A-GaME implementation team, and continues to be an advocate for the A-GaME and geotechnical exploration methods with geophysics and others. So right now, Dustin is a project manager and has been in that role since 2019. So those are our panelists and our speakers, and the idea here is to have an open discussion among all of us. And I encourage you in the larger audience, the audience at large, to put in your poll or your questions within the question and answer pod or chat pod, and we'll get to those in this first part. And before we, as those come in, if there's none right now, I am going to open the floor to our owner representatives here and see, what questions they have to our speakers to start things off. So Sarah, Kevin, Peter, Dustin, do you, anything that you want to ask starting things out, or share comments that you, from what you've heard?
Ben, I've got a question, I guess, to start us. Just to ask our panelists, what are some innovative ways that have been used to manage risk on a contract?
And if everybody would turn on their, if you're comfortable turning on your cameras, that would be great. So that I think that sort of makes it easier to talk. So Kevin, you were looking for innovative ways of contracting?
This is like within a project that maybe they've worked on. What have been some examples of innovative ways they've handled risk on a project?
So I can go first. I spent 25 years on the design side. So my approach to managing risk for PennDOT was basically to make sure that we knew as much as we possibly could about the subsurface conditions, any potential problems we might have out there. And we've done a handful of things that have been innovative for us, looking at different foundation types. And on a project a few years ago, there was some disagreement, as there typically is in the geotechnical community, about how much settlement was going to occur under brand new embankment. We were replacing the embankment to eliminate bridge structure. So we actually built and monitored a test embankment to get real data, and it enabled us to not just build the embankment, but be confident in the amount of settlement that would occur, and to find a structure that could accommodate more than the 1 inch of settlement, which is typically allowed. So, I've promoted over the years, don't do 2 borings at an abutment, do 3. What's the soil profile? Do we need to do CPT? Do we have running sands? Let's make sure, we really understand the character of our subgrade and try to optimize our foundations, because the cost of investigation is so minimal compared to encountering something in construction. We just had a case on the other day that didn't hit rock where it was expected to. Because we needed to make it so much deeper, they needed to get a whole new diameter shaft and do a redesign during construction. So it was because we didn't have a boring at that spot, because there was railroad and slope and all kinds of problems. So that's always been my approach. I'm relatively new to construction. I just started in September, so I'm learning how to look at things from their perspective a little better.
And this is Peter Davich, just to speak for Minnesota. Had a project with Mr. Dazenbrack, who's on the call here today, where we were trying to stop a very deep slope failure up with some fat clays in the northern part of the state. Long story short, in regards to investigations, the investigation risk, nothing earth-shattering. We took many, many borings and investigations and made all of those, guaranteed information. We didn't necessarily guarantee any interpretations between the different boring and CPT and other sites, but we did, cover the site very well. The one I'd mention here would be that the risk that was most interest to us was the risk of design performance in the long run. Would whatever the team gave us, stop this creep and slide from occurring? And we weren't trying to specify one design versus another, so it was very difficult to, if somebody gives you a panels down at the bottom versus pounding in a bunch of piling versus soil mixing, those operate differently in regards to geotech conditions, of course. What we ultimately settled on is for the 3-year warranty period following the design, we said we want to see the creep be no more than this in any of those 3 years. And we thought and found and talked to the industry a little and found some levels we thought were reasonable. And then we said, because this site actually creeps when the water level of the adjacent stream is low, when the water got low, there was less pressure on the bottom of the slope, so it was more likely to slide. That would actually, void the warranty requirements and let the team have additional creep during those 3 years if there was a drought of some sort. So actually, that was my favorite project. That turned out very well, but it was very difficult setting up conditions that would cover our risk of design performance.
Good. So, Steve, I think you might have been starting to address.
Yeah, so an activity. So we did 2 segments of the light rail system in Honolulu, and a very effective approach for that design build project was a geotechnical baseline report that Parsons Brinkerhoff prepared for the city and county of Honolulu. With it being design build, they had explorations that covered about 20% of the area, and a project that involved drill shaft foundations every 150 feet for 25 miles. And the project is completed, and the geotechnical baseline report was extremely successful in defining the ground conditions at the time of bid and finding an opportunity to be able to integrate the borings that were done as part of the design build project with the borings that were done at estimate time. So we just have seen great benefits being derived from geotechnical baseline reports for transportation structures.
Very good. Anyone else? Oh, Rick, you're on mute.
Thanks, Ben. I appreciate Peter's comments to start off with, because that was a job that Nicholson did, so that was fun. Anyway,
Wondering if that was going to come up.
There's another job we're doing with the Minnesota DOT, which I think the contracting method worked well because of the uniqueness of the project, and it's a CMGC type project for the I-35W drainage stuff. But I think to me, the communication between the design side and the contracting side needs to happen somehow in order to really try to envision what kind of risks are available and what kind of data is necessary for the various approaches that might take place, right? If you're coming right out of textbook type of techniques, and maybe not so much, but if you're looking for unique ways to do work, there needs to be a good exchange between the owner's designer and the contractor to get a comfort level on both sides moving forward. And the CMGC is one method of doing that, or some type of early contractor involvement, I think, is really important, because it just, the contractor is going to have different risk tolerances than the owner and the engineer. And sometimes the owner has a relatively high risk tolerance because they're trying to manage a budget. Getting everybody around the table and talking is just the best way to do that. And often it leads to additional subsurface investigation needs for the various techniques that could be, flushed out. but there's got to be the conversation. Routine projects, not so much, but if there's any level of complication, both sides have got to be talking. They've got to be able to talk openly and sincerely in order to get to the best solution.
Yep. So I'm hearing, detail on making that effort for characterization, the communication, innovative ways of providing that information through GBRs and CMGC as a mechanism to communicate among the stakeholders. I think all of these have are the parts of success in the early characterization and the communication part. We've got to solve that issue. Coming from the standpoint that we, in many cases on projects, we are driven by sort of the early stages of project requirements. It may be in the scoping part and then getting into the design side. But when is that construction aspect, and how we actually communicate that? I think that's one of the challenges that we have here. And it sounds like the CMGC is one, but just sort of adding to Kevin's question there on the innovation side, how do we make that happen up front?
I guess the one thing that the project that Peter brought up, another unique part of it, it wasn't just straight design build, right? They had thought it through substantially and developed the performance criteria that they wanted. There were, I think it was 2 meetings that they had with the individual bidders. The bidders were pre-qualified in advance. They had to have qualifications and they were approved in advance who were going to bid the final project. They provided a stipend because it was such a big effort to put a detailed bid together. They provided a stipend. I think it was $40,000, which wouldn't have covered all the expense, but it was an effort to show good faith that we're looking for, really thoughtful type of approaches. And then we had meetings. There was a couple of meetings where you sat down and you were able to vet your ideas, and so you didn't go too far off on a tangent on something that they would think it was, maybe too obscure. And so, there was a significant effort that was necessary to make that design build project work. It wasn't just, I'm going to put it out design build and here's the information and come back to me with your lowest price. Because especially with slope stabilization projects, there's a very, very significant effort necessary to do the design. And if you got 7 bidders and you're going to be one of 7, how much money can you really invest in doing a detailed design when the odds of you not being successful are so high? So I think that those types of considerations are necessary if you're going to be successful.
Yeah, and to add to that, on the Menard side, where most of our involvement in DOT projects is going to be as a subcontractor, I think where we found the most success, particularly in the bid build space, is where the owner or the engineer recognizes that maybe there are some geotechnical challenges in an area, and on the plans they just kind of hatch it out and say, this is what we want this embankment to do. Come to us with your best solutions. And so just portions of the project end up being design build, but what that allows is the agencies to get, the experts kind of, best ideas at the bid time as well.
This is Steve. I would also believe that many projects have 1 or 2 geotechnical problems that are pretty apparent early on in the design phase. And I think it's important for the designers and the DOTs to look at that and say, have we gotten enough information and have we gotten the right information so that the designs and the analyses address the problem. I mean, we've seen multiple instances where it's a settlement problem and all you have are blow counts and maybe some water contents. So some level of sanity that would say, you know, if I got to design this, have we provided the teams the proper information and so that you can put a reasonable and in some cases aggressive proposal that hopefully addresses the problem and doesn't cost a whole lot of money.
Excellent.
Yeah, I'd second that. In Minnesota, I mean, I can't tell a lie. We haven't been using something that I would call geotech baseline reports. We've considered it. We tend to do it more piecemeal and kind of guarantee things here and there. But the way we typically think about it is, look, we provide all the information, we provide ourselves, we guarantee that. In some cases, like you say, there are holes left, and you know that the teams are very much going to wonder what the borings are over here, or if there's some sort of soft spot over there. And if we are aware of particular risks that are out there, we say, look, either we don't want to make you all have to bore this. You can assume that this is going to work this way. So kind of do a guaranteed statement in one area. Or if you find muck in this area, we're going to pay for it via change order. We try to think that through up front and put those statements in, and then even give the contractors a chance during procurement to say, look, you know, several of us are very scared of this area. Is there anything more you could do to kind of help protect us from this or discuss it? And as long as it's early in the procurement, we might still add some protections or shared risk pools if we're hearing that there are significant concerns about an area.
Very good. I'm going to ask our panelists here in a second, you know, if there are other questions here, but I did want to point out that John sent a chat just letting people know that there is an NCHRP study directed on the question that Kevin was asking earlier, that does talk about managing geotechnical risk and progressive design build. Was that, I'm trying to remember who actually put that together. Was that the person from Iowa State? Does anybody know right off? John might put that, but I'm thinking that might have been, yes, yep. Very good. So yeah, that's certainly a good resource. So yeah, from our panelists here, you know, other questions to our contractors?
Well, I just have one more thought on that last
Okay.
question. There is, you know, at least in my agency, we don't do a lot of design build or CMGC. You know, we're almost predominantly in the design build world with, you know, we're not talking $1 billion, you know, design build projects. Yet we still have lots of geotechnical risk on projects, and that's one of the main areas where we end up having problems down the road. So, you know, for us, it's usually up to like, how can we make sure we've characterized the site as well as we can, synthesize all that data into something that clearly, you know, shows the information and the obstacles that we see. But, you know, my question is, I love the early contractor engagement. I usually just can't do it. And you know, thinking through these constructability things, I mean, you know, one of the things that we've done is, you know, occasionally I'll be able to, for a smaller dollar amount project, I'll be able to, you know, basically sole source the work and actually work with that contractor. Say when we're at about 95% design, it's a little late in the game, but at least at that point we can start to figure out some of their questions and their ideas. Because, you know, for a geotech engineer, you know, it's just, to be honest, most of the geotechs out there, you know, we don't have tons of construction experience, and so it's hard for us to visualize sometimes exactly how something's going to get built. So, you know, we're always looking for those set of eyes, and that although I think we're doing this a lot on these really large projects, it's more that medium-sized to smaller project where you don't really have that opportunity. So I think it presents a bit of a problem there. So
Just practicality, right?
Yeah, and are there, we've had some other projects where again we're going design bid build. We've had almost like we call like an industry meeting or something where we pulled in a few contractors and we brought them out to the site and said, hey, look, this is what we're thinking about doing in this area to try to get feedback. And we, maybe we can present some information at that time. It's really for the, I guess where this all leads is, the more I've been on the project manager side where I've been interacting more with contractors, it is all about risk. And it's, there will be risks no matter what in the project. It's the contractor. What we need to do is figure out who's bearing the risk. Is it going to be on the owner or is it going to be on the contractor, and making that clear, because a lot of times on the design side, we don't always understand, our designer who's been designing projects for a year, they just saddled the contractor with a whole bunch of risk by the way that they wrote this up. And they don't even realize that that's what they've done. And so when you get that opportunity to discuss, the contractor can say, hey, look, this presents a problem for us. Can you see how this presents a problem for us? And then, oh, well, that wasn't even our intent. When we have that communication, we can usually figure out a way around that. So anyway, I guess what I'm saying is I kind of went in circles there, but my point is I totally agree with that. I do find there's a bit of a challenge for these kind of medium-sized projects where I don't have, the ability to do an alternate.
Yeah, Dustin, I'm going to second that. Pennsylvania doesn't really do design build. We have specs for parts of projects like retaining walls and sound barriers and things like that. But as a rule, we don't do design build. So we really are saddled with and obligated to provide as much information to those contractors. And one of the things I learned early on when I started being a leader was that the absolute best people to learn from were construction. I would go out to every single job every time they dug a hole or drilled something and learn. And I've told everybody that it's ever worked for me, go out to the field before, during, and after construction if you need to. And just by having those conversations, it's twofold. You learn from them, what works and what doesn't work. I mean, a silly little thing like a mud slab, whenever we have spread footing on soil, it's cheap, it's easy. And all my guys were like, why aren't we doing this? It's so cheap and easy. And it helps reduce risk, especially on, softer soils or over creeks and things. The other thing it does is it builds relationships with contractors. And I feel like as an owner, historically, contractors have been looked on disfavorably. They just, want to make more money, and that's their only game. Well, I ended up marrying a contractor. So, I know that
that's not true.
Yeah. I know it's altogether not true. I mean, there are some slime balls out there, of course, don't get me wrong. But, the majority of the people that I deal with, one of the project engineers on two of our biggest sections of 95 and the biggest project Pennsylvania ever let is a geotechnical engineer. And he and I developed a professional relationship, and I have learned so much from him. And he and 4 or 5 other guys, you can call up and say, hey, this seems a little sketchy or fudgy to me, or I feel like there might be some extra risk with this, or can you think of another way to do this? And, there's ways to share information and ask questions without feeling like you're being unethical or giving anybody any kind of advantage. But I think that's really important for owners and contractors, because we all have the relationships with designers, but those relationships with contractors are immeasurably important.
I agree 100%.
Yeah, I also think that develops trust too. Like it's, not just a risk thing, but if everybody kind of knows each other and trusts each other, they're less likely to, more likely to communicate something in a productive way than for something to go wrong down the line.
communicate and work together to come up with a fair and reasonable solution.
I think and again, I've worked in the consulting side and in academia, and I do think there's a bias of less trust for contractors than there is in other people in our profession. And in my experience, there's unhonorable people in all walks of life. And contractors are, for the most part, trying to do their job. The challenge is we're at the bottom of the totem pole, right? So, and the risk and the contractual language and stuff flows downhill, and we're working on relatively small margins. And so people can get jammed up and they feel they're being untreated. They're just trying to, like they're a cornered animal, right? You're just trying to stay alive and keep things rolling. And so it's difficult. To me, the collaborative approach where everybody understands the risk of the ground, and especially when water's involved. Steve said this earlier. When you've got water involved, it always exponentially increases the level of complexity of construction. And it's almost always oversimplified because the solution is expensive, right? To deal with it upfront in a very positive way is generally very expensive. So people put on their wishing hat and hope that it's going to work for the best. And when it doesn't work for the best, then it's a matter of who's responsible.
So, so what do you mean by expensive upfront with water?
I mean, anytime you've got groundwater and you're having to deal with it,
right?
It generally gets oversimplified, right? People always remember a job where they put a sump in the middle of the excavation and it drained down the water, and that was easy.
Right.
And they didn't realize, they were in a beach sand someplace, and it was ideal for that. And
just the complexities
of stringers of fine grained materials can just wreak havoc to that stuff. And once you're already in construction, it's really difficult to deal with because time is so valuable.
Right.
And but dealing with it up front is also a big cost that people want to wish away.
Well,
right?
and I think that brings up a great point. I mean, but how much money are we talking about, relative to the problems, the risks that it poses? And we traditionally, you are spot on. We do a terrible job characterizing groundwater conditions if we even get, an elevation of water, before pulling off a site. And we can change that. That is an area. In fact, the A-GaME recognizes that is, in fact, the NCHRP synthesis recognized that was like one of the top areas where we run into trouble. It's the characterization of groundwater. So what do we do, to make that happen?
So this is Steve. I mean, I think you look at your boring logs. Do you have delayed water levels? Do you have any information on where the groundwater level is? Have you installed any piezometers to be able to give you a delayed water level? Do you talk about seasonal variations or other variations in the groundwater that would be particularly important if you're down in a cut, if you've got to build cofferdams regarding to construct structures and all that? But my opinion across the country is that there's always a reason that you got to backfill the boring immediately. There's always a reason as well. Okay, I just didn't get that information.
I think you might mean an excuse.
Okay, but that's a point of things that we see as to where if you could improve your explorations and investigations by paying attention and getting the data. I mean, much of the problems we see are because there isn't information, or there is a case that was no information at all. So, that would be a particular thing of go to your manual of geotechnical manual of instruction and say, did I follow it for this exploration, for this job?
Yep. We're getting, yeah, go ahead, Jim.
What about a post-bid geotech report? Okay, an allowance in the job, and then after you get the job, as Steve was asking all these questions, hey, we want well, geotechs work cheap, so we want $2,000 to go drill some more holes. No, you know what I mean. You go in there and, hey, these are the questions that we have. You want to minimize the risk? Let's go drill. This is the information we want.
Yep. And
put
that
an allowance in there for that.
Yeah, so that sort of now we're, on the practicalities of being able to do what we can do. This actually brings up a very interesting point on geotechnical baseline reports, and I'm not very familiar with is it the CM, or it's geotechnical baseline report for construction, but same concept here is that we could plan an investigation specifically for those types of questions. I don't know exactly what that looks like, and maybe you guys do know what that looks like. Any experience with that?
I don't, but I want to hop in real quick. There's a corollary to the groundwater, and that is on one of our first sections of 95. The ground was polluted. Therefore, the water was polluted, that every gallon of water that we had to pump out of the ground for whatever reason, dewatering, had to be treated. And that was an unexpected and surprising cost and very unfortunate. So, going forward, we use the lessons learned about staying out of the groundwater as much as we can. But there's the corollary to that is we just had an executive meeting about dirty dirt, we call it. So it's not just characterizing what your soil is and where the water is, but what is in it and what do we have to do with it and what are the costs associated with that as well. And how do we try to have, not have waste jobs?
Right.
So there's just so much that goes into the puzzle. And it's what I find is that, the conversation is like, we need to do more testing. We need to do more testing. And I feel like that's sort of the consensus of geotechs always.
Yeah, you're right. To sort of expand, our knowledge and I think that's an excellent example of the fact that things that we don't necessarily think of that impact a project and construction. And, we do know about hot rock and other things that we can anticipate, but we always are going to have, conditions that we, can't, but the fact that we're not seeing the entire picture as a geotechnical engineer is one of the challenges to, appreciate that there are other, decisions that have to be made that we don't know, what impacts those are other than our little world. So there was actually Peter actually made a great point here, and this actually ties into sort of the characterization of groundwater too, or it could. We could do more investigations with piezometers and other instrumentation, but Peter's question here is how?
Yes.
Yeah. Go ahead. You're here. Why am I?
Sure.
Asking question?
We've had a few projects in the past, and again, Mr. Dazenbrock is involved with some of them where we were coming through and saying, hey, we're requiring these geotech designs. And again, with the belt and suspenders approach, how much do we need to kind of monitor how they're working immediately afterward to make sure we got what we wanted? And we kind of shift back and forth on that because the instruments themselves cost a not negligible amount of money. And the projects where we have put some requirements in there to monitor, for example, how quickly things are settling or groundwater moving or whatever else you want to say, the contractors usually come back and usually what they say is, hey, do you know this instrumentation costs a lot? And they say, well, yeah, we don't generally know how much it costs. I always kind of wondered what they actually mean is, can you get rid of this because I'm nervous about how much you're watching me because I know there's warranty provisions and it just makes me uncomfortable. So a high level question, basically, contractors, do you feel intimidated when we put a lot of instrumentation requirements in contracts, particularly if there are warranties on settlements and related things?
I think there's probably two answers that I would give, and one is that sometimes if the instrumentation is really expensive, the contractor is worried that someone else isn't going to include that and it's going to make the difference in their price, right? So they want to ask the question. So the response is, yes, you have to use that so that there's a baseline that we're not going to make any exceptions so everybody's on the same page, right? So sometimes that's the question. I would say that in general, I think it's appropriate to measure performance because that's the only way we're going to learn. The tricky part is when you're asking for too much, right? Like you've got a supportive excavation system and you say, I only want a 1/2 inch of movement, and you don't need a 1/2 inch of movement. And a 1/2 inch of movement is right on the edge of what can be done with the most cost-effective system, right? And so, we've been in jobs like this, usually in the private sector, where you sit down and you have a good conversation and say, look, you can have 1.5 inches of movement here and you're going to be fine. But I can design it for a 1/2 inch, but I'm going to have to overload my anchors or my struts or whatever to get you a 1/2 inch, and that's going to cost more money. And again, it's trying to make the playing field fair, saying, if you're going to hold me to 1/2 inch, you got to hold everybody else to 1/2 inch because your system's going to cost 50% more. Or do you not really need the 1/2 inch? And so sometimes a contractor might say, well, I don't want to do the monitoring because I know it's going to be more than a 1/2 inch. I know no one's going to even notice, and everything's going to be fine. And so the only way it could not be fine is if somebody measures it and it's 3/4 inch, and then all of a sudden I'm shut down for no reason at all. So to me, it's a matter of making sure what I'm measuring and requesting in performance is the best value for the project, because it's not better to have too much, right? A lot of times you'll see in this business, people want more, they want bigger than necessary because they feel like they're getting more value than they need. And in reality, we're engineers. We're trying to give just what we need to meet the specifications at the most reasonable cost. So making a pile bigger to sleep better at night isn't really the solution. That's not why we're engineers. We're there to design the optimum solution. So don't ask for more than you need. That's essentially the result. And then if it is 1.5 inches you're asking for, and that's the reasonable amount for the utilities nearby, by all means, let's measure it, because no one wants to wreck the utilities. We all get dragged into it.
One of the NHI instructors said, in which course I can't remember, Ben, but it reminded me of this. He said, over-designed is under-designed because you're under-engineering. Yeah. Is what you're doing. And it's, you could get a college kid to design something that's safe, but where's the thought and the experience in that?
Where's the value?
And I think philosophically, and I don't mean to monopolize things, but philosophically, and I've worked on a consulting side and I've seen this, and it's kind of inherent sometimes. I get overgeneralizing, but sometimes people over design because they don't know who the contractor is going to be. And so they want more just in case, right? But the reality of it is, if the contractor doesn't do his job, you can't design it well. There's nothing you can design that's going to make it okay if the contractor isn't going to do his job or the quality control, quality assurance isn't in place. So that has to be a part of the solution. So over-designing doesn't solve that problem. So that we shouldn't have that mentality that it will, in my opinion.
And you have a whole different set of people in charge in the field. There might still be owners, but you don't know what their experience is and what they might allow or disallow based on that as well. I mean, the knowledge is just not shared across enough.
I agree. And again, I'm on the soapbox a little bit here, but when I started my business, or not, when I started in this business, the designers typically were involved in the quality control. So if you were working for a good designer, your young people were on a job site making sure things were built as they were supposed to. So they got the feedback of the constructability, and they were in there negotiating, say, well, that's not quite right, but I see what'll be good enough. You go ahead, keep moving. Let's keep this project moving. And you had that experience. And then it got to where the owner could buy the quality control, quality assurance for cheaper than that design engineer's cost. And so now there's a disconnect between the inspector and the inspections organization and the designer's organization. So you never have the feedback loop. And the designers now don't see the problems that you have on a job site. In fact, there could be alternates to what they designed being installed, and they don't even know that, right? They think there's drilled shafts on there and it's auger cast piles. And sometimes they don't even get that feedback. And so that whole feedback loop has been lost because of, trying to save money in terms of the inspection part of the process. And it's really hurt the knowledge and knowledge of constructability on the design side, in my opinion.
And it's an equal problem on the owner side as well. I mean, let it and forget it is what I hear. And I mean, our people are good here at PennDOT. Don't get me wrong, but when changes are made in construction, nobody's dropping the designer an email or the project manager an email or the owner or whoever, or the geotechnical engineer or the bridge engineer. I mean, often things happen and change without that feedback loop. And, you know, the only way to remedy that is to have either a system in place or to ask people to do more than they're already doing. So it is a challenge. I agree.
Yeah.
So for our Interstate 15 project, we had the problem of determining when you could take the surcharges off. And that was a problem in spades. And so the system that we set up was that we had an instrumentation package that was designed by our engineer. It was installed by a third party. And then the monitoring results went back to the designers. And the designers, and there was a hold point to where construction could not proceed with removing the surcharge until the designer issued in writing an authority that said that the settlement's done, the work can proceed, you can remove the surcharge. And that was relatively effective in that it took the certain decisions away from the field superintendents and turned them back to engineering. And we've done that in a variety of other projects and implications, but I would hearken back to the idea that you want the design geotechnical engineer involved in construction for a variety of very specific things. And we can organize our teams and we can organize our approaches so that we make sure that that designer does have the involvement.
I think that's a fantastic point. I mean, fundamentally, that is sort of you know, a root issue. It's in. I know Jim and I have talked about the, you know, experience level of people coming out and the fact that they need to be aware of how things are constructed, but the communication part is. You know, the field involvement of the designers is historically, it's terrible within, you know, the structures group, certainly. And on the geotechnical side, I don't think it's too far better there. So I think that's a great point.
Yeah, I think there are lots of things that, you know, it's a lot of pieces to the puzzle, right? So
Right.
You have, you know, some owners that, you know, potentially, you know, select very expensive systems because they're very redundant, or maybe they don't need as much inspection. So, you know, I'm going to go with a cantilever wall because I only need to have my inspectors out there once or twice, right? Forms are up, they look good. You know, steel's in, it looks good. Concrete was poured, looks good. You know, inspector only needs to go out there 3 times, as opposed to maybe a mechanically stabilized earth wall, which could be a third of the cost, but maybe needs, you know, daily inspection for what's going on through the entire construction of it. So, you know, there are definitely things to think about. But I think it is important to continually stress, especially for complicated projects, having the design engineer of record involved in the construction. You know, I've seen number of things where, you know, things were obviously wrong by the time they were built toward the end, and there was insufficient oversight, and it could have saved a lot of money taking down and rebuilding it if there had been more, you know, supervision to make sure it had been, you know, constructed appropriately. I've actually written contracts where there was time and money in to say, you know, the design engineer, you know, shall be at the site during construction to make sure that they were, you know, available to the project as it was going on. I think Ricky made an excellent point about having, you know, reasonable expectations for the measurement. You know, I have written a lot of performance specifications, and I wholeheartedly agree. You know, I like to know what's going on, but I don't think having tolerances that can't be met or or below the position of the instrument, do anybody any good. But I've also been on a number of projects where the instrumentation certainly has changed minds, that we were monitoring settlement, and it wasn't popular to keep a detour on over the winter months, but the settlement clearly wasn't done. So the owner decided, I'm not going to waste money on paving this if the settlement was only half as fast as we expected it to be. So they kept the detours in place for another construction season based on what the instrumentation is saying. And had they not had some pretty robust instrumentation there, in this case, I think it was satellite-based systems to show, a very nice curve that wasn't meeting the mark. That if people had only gone out there maybe, occasionally with stadia rods or something, wouldn't have had the precision to, kind of allow the decision makers to make, what I feel was the correct decision. And I think it did save overall the project. People often complain, well, I need to be detoured for another few months, but I think they would scream a lot louder if the road they just built was all broken up within a few months after new construction.
Yeah, I think back to the feedback loop, as Rick called it. It's a slow evolution, because I feel like, especially in construction, design too, we just keep doing things the way we've always done them, and change is hard and it's difficult. We're using some kind of SharePoint system now where more things do get back to the designers for changes or RFIs or things like that, and it's so much quicker because of that. But it takes time. I mean, we just put together, myself and my constructability reviewer, like a constructability sort of policy. Like this is when we have to do it at this point in design and for this magnitude of job, and these are the things we need to look at. Tell us what else we should be looking at, and included in that is after action reviews, which we as a practice don't do as a practice anyway. So adding those things in and having a formal method and sort of process for doing that, adding to the things you've always done, especially when they can be a little more efficient these days, I think is helping.
Yeah, and I guess just from our subcontractor point of view, I mean, we are not afraid of instrumentation and testing. We welcome it. I think, you ask any geotechnical engineer a yes or no question, the answer you get is it depends. And it's very much true with our techniques and applications. We run, our sophisticated models, but ultimately there's still going to be a degree of observational geotechnics involved in the work we do. So it's hard to give a complete answer without the data to appropriately answer it. So we love it. We love to see it.
Several years ago, I went to a real interesting conference at dam safety conference, and all they talked about was their failures, not about their successes. Really interesting.
Yeah, Ben, one of the things I loved from the very beginning about HGS compared with ASCE conferences, it's exactly that. This is what went wrong, and most of the time it's not our fault because it's nature or it's the soil or it was a rain event or something. And I learned more from hearing about failures than how great your bridge design was.
That is, I haven't really put that together, but for people who don't know what the HGS is the Highway Geology Symposium, and they've run a fantastic program for years. And much of that has to do with lessons learned and the complexity of geology and how that impacts, these projects. And so it is exactly what Jim sort of described. It is more cases of failure and lessons learned than anything else. And applying that, in fact, the great part of the HGS too is for years they have kept proceedings. They are accessible. In fact, they've digitized those too.
Yeah. Next year, it's in Tacoma, Washington. I'd encourage anybody in the area to come along or be a
Yeah.
sponsor.
Yeah, for the geotechnical engineers who have not been exposed to it, it really is, one of the greatest conferences that I totally agree with Sarah.
Yeah,
a
and
great conference.
it's in a different place every year too. So you get to move around, and there's a field trip.
Yeah.
Um,
And you get to interact with geologists who like beer, but they really, the fact that they understand and are coming from a different perspective, but most of the geologists there are engineering geologists, and it is a great interaction to get a different perspective there too.
yeah,
So
I mean,
Ben-
I have reached out to other state DOTs with problems because I met the guy from Kansas or the guy from Washington or the gal from Vermont at HGS. So.
Yep, there's definitely a lot to be gained from networking and peer exchanges, much like today. Ben, since we've been talking about lessons learned, this seems like a good opportunity to see what we learned from our participants in the polls this morning.
Very good. Yeah. So, do you want to run through those, Derek? So these are the raw. So you're planning to discuss those before we get into the discussion?
Yeah, just to run through them quickly.
Okay, go ahead.
I figured people took the time to vote. We should let them know how the results are. And certainly if our panel has any thoughts on whether or not these were maybe what they anticipated from the questions. So they're grouped by topic area. So question 2 will be forthcoming. But the first question, most geotechnical specifications are well written and have realistic expectations that consider constructability. We had about a half and half split there. So it appears perhaps there's work to be done on well written and realistic expectations. Did any of our panelists this afternoon have any thoughts on that?
Holy,
I guess
the definition of realistic.
I was just going to say, as a person who writes specs, I was expecting worse. So that's not bad.
Yeah, I did bring this to my contractor husband last night, and he agreed that most specs were realistic. But
okay.
He does. Yeah. He's in heavy structure construction, so he's definitely dealt with foundations.
Yeah, okay. I guess my answer would be it depends. It can vary from state to state, agency to agency, even technique to technique. Some of them are very well written, and we feel protected going into a bid with it. Some of them, we feel that it places additional risk on us, which ultimately leads to additional contingency we have to carry, which is additional costs for the project.
When you feel there's additional risk in a spec that you're seeing on a project that you're bidding, do you ask the questions to try to get clarification and reduce your risk?
Yeah, for sure. We're typically going to be a step removed. So we're submitting our RFIs to general contractors, having them submit them. We are trying to have as many detailed, comprehensive discussions with the general contractors leading into the bid, so that they understand our concerns. Our proposals are, typically like 6 pages, including diagrams, drawings, clarifications, specific clauses called out in the specifications, and how we're interpreting them, as well as what we think that risk may carry. But ultimately, what makes it into contracts, our scope of work, hopefully all of our exclusions, but maybe not all of them. And sometimes, the ones that we've had, who we think are our horse going into a bid ultimately aren't the low bidder. And so it's just like another degree of complications involved in it.
Well, I think a 50-50 split probably represents the strong "it depends."
I think a lot of it relates to the technique as well, right? Routine techniques. The specifications have typically evolved to be pretty buttoned up, and when you get into something unique like grouting or those types of things, there's probably less experience from the writer, less baseline specifications available to work from as a boilerplate. And then it's often more difficult for the inspector to interpret, right? Because he isn't knowledgeable of it as well. And then the approval or non-approval has more to do with the personality of the inspector than maybe it does with the specification in terms of what's tolerable or not tolerable. If somebody wants to hold you by the book, but they don't really understand what's important, it can make it very difficult. And other inspectors don't have that same type of concern. So there's that part of it. But, you know, I think one of the things that when Brian was talking, made me think about is that as subcontractors, a lot of our work is supported by the general contractor, right? So we talked about qualifications or support mechanisms. There's different things. It could be earthwork or whatever that we would rely upon them to support us in our efforts. And so there's that kind of scope back and forth that has to go with in our negotiation with the general contractors.
Yeah, Rick, you brought up grouting. One of the things I decided to do about 10 years ago was not let the guy who's inspecting paving inspect the grouting, and make sure we have a provision in our design contract for a designer to send a geotechnical engineer or geologist out to inspect the grouting. He knows what he's looking for. He knows what the intent is. So
Yeah.
that's been really successful.
Yeah, but just to be, I'll say something you probably won't believe me, but I have seen jet grouting specifications where it was a permeation grouting specification, and the only thing changed was the title on the specification. It said jet grouting, right? And that was the only thing. Everywhere in the whole specification it says permeation grouting, permeation grouting. Wow. And it was, you know, so you get some pretty wild ones out there. But yeah. Anyway.
Yeah. Their search and replace didn't work too well, right?
They didn't even try. I don't think, didn't even try.
But I mean, that brings up a good point, though. You do suffer from cut and paste by people that think that some of the geotechnical techniques are equivalent to other portions of engineering, right?
Yeah.
Like it's exactly the same. Instead of a left turn sign here, it's a right turn sign. Just change that over. The spec will be fine. Who can best manage geotechnical risks? Select all that apply. Pretty even split across a diverse responsibility there of who's best managing the risk. And that probably reflects that it makes sense that sort of one of these three-legged stool considerations, right? If the owner wants a good project, they're going to need to make sure that there's good engineering and contracting behind it, and a contractor should have a reasonable expectation that it is a decent and constructible design that they were provided. So I don't think anything there is particularly striking.
If I get to say it first, I just say it depends. Depends on the risk, depends when in the project you are, but it's a three-legged stool. Everybody has to work together to really do it correctly.
Yeah, and certainly the most successful projects are the ones that have good relationships among the owner, the consulting world, and the contractors, because you can easily certainly come to stalemates if you don't have good partnerships and trust in all the parties. So on geotechnical risks, geotechnical investigation for driven pile foundations is different from that from drilled shaft foundations. By a large margin, that statement folks agreed with. Any thoughts on that from the panel?
I always approached subsurface investigations knowing that we could end up putting anything in. Unless we absolutely know it's going to be a spread footing on rock, we have to plan an investigation for all of that. So, it doesn't matter if it's going to be, now I did agree with this, of course, because if you know what you're putting and then you do that accordingly. But you have to account for whatever you're going to find out forming your decisions.
Yeah, so just thinking about the fact that so little thrown off on the questions sequencing here, but collectively, so we're actually on that first grouping of slides. We grouped those as constructability, and now we're talking about geotechnical risks. What are the risks involved with not recognizing the fact that those are different elements and they're different, needs? And how significant that, in your experience as contractors, you get minimal information to begin with, but what information would be different there, ideally?
Well, this is Steve. I mean, particularly for drilled shafts, I mean, the first question is going to be, are your means and methods? Can you drill an open hole? Are you going to have to support the sides of the hole with a slurry or water? Do you have to rotate a casing into the ground? Do you have obstructions or things that are sitting on top of your bearing layer? So there are, I think, a variety of things that are geotechnical risk there if you're going to try to go do drilled shafts. But by the same token, if you're then taking a precast concrete pile and driving it to tip, maybe your information you need is less or certainly different.
Different, yeah, absolutely.
Yeah. Ben, I think this is an interesting question because for me, it sort of drives home the thoughts about constructability, because you don't construct a pile and a shaft in the same way. Right. So there are different aspects. Steve brought up the idea about whether or not you can do it, in an open hole, or whether or not you need casing or slurry, and then have to deal with potential spoils. We talked a little bit earlier about environmental contamination, which could be entirely different if you need to change means and methods. A single large drilled shaft, which might be a monolithic element that doesn't have redundancy, if you can't build that in the spot where it is supposed to go, there's a problem there. Yeah. Where oftentimes if you have 10 or 20 piles, often you can jiggle them around a little bit in the foundation footprint if you run into an obstruction. That's difficult to do as elements get larger and non-redundant. So yeah, there are different aspects. The corollary might be piles might need a cofferdam design that requires different investigation as opposed to single element shafts that go down once and you're done. So it is interesting that what you're building does have some additional relevance. I would also argue that because it's relatively easy to extend the depth on driven piles, and it may not be on drilled shafts if you've ordered your cages and your steel and other things, that it makes a somewhat bigger difference in your site characterization for your layering with drilled shaft construction than it does with piles.
Yeah, I think this is a very simple, straightforward, single example, but it kind of highlights the need for, what we were discussing before about asking the question, is that one initial geotechnical investigation enough? And is there, if things change on the project, or if you're changing your method, or if the contractor actually needs more, are there avenues for additional investigation, and is that worthwhile?
Interesting while you're talking and thinking about, several jobs in the past in Chicago, working for a contractor, we have the drill shaft job, okay? And the drill shafts are supposed to terminate in the hard pan, 15 feet below the surface, okay? So we get out there. Well, what happens is we're going to work from the pit rather than working from the ground level. So we dig the damn pit and walk the rig down there and start drilling. And the inspector says, 15 feet. Okay, it's pretty hard stuff. 15 feet. We broke through the hard pan, and all the other drill shafts had to go 80 feet to the rock.
Wow. Wow.
And that goes back to how you're going to do the job, this, that, and the other thing. Well, we're not doing it from the original ground elevation. We're doing it from a pit.
Yeah. Well, and I think it also brings up some other interesting aspects, right? Like if you're expecting the foundation design to, say, go to a certain bearing strata and then it doesn't, or someone comes in and value engineers it, and now you're going deeper. If none of your borings go that deep, then you're in uncharted territory because of potentially a change in design. So I think there are a lot of interesting aspects to that question. Number 5, are geotechnical risks similar to other risks in civil engineering? Most of our respondents disagreed with that statement. Any thoughts from our speakers and panelists on why geotech is different?
I started thinking about the risks that a contractor takes, for example, right now with inflation, and we don't know what things are going to cost in a year, and they didn't know 6 months ago and they got a job what things were going to cost today. So, because my first thought is always unknowns. There's always more unknowns with geotech. So, that was sort of my perspective. When it comes to actually constructing something, we have more unknowns than any other aspect of the field, but there are other risks that are not engineering risks.
Yeah, I've often used an analogy when I've been doing some adjunct teaching that about the great degree of variability in geotechnical engineering that is not present in some other disciplines. And I often say, it's like, well, suppose when you're doing your hydraulic design that the viscosity of water could really be kind of different. It could be watery, or it could be peanut butter or mayonnaise, and you don't really know until what you're going to get to the site. But just incorporate that in your calculations. Either that, or to the structural engineers, well, we specified, 4,000 PSI concrete in that beam, but it might be 100, it might be 16,000, or it might be wood or steel. It's whatever they got in the shop that day, and you're going to get it when you get out to the site, and then it'll be revealed. Please provide your design. And they kind of look at me quizzically, and it's like, well, those are silly. And I'm like, yeah, but I think they draw a reasonable parallel to the fact that you're not always going to know, in geotechnical engineering, what Mother Nature put into the site, and things could be different unless you've done a very good site characterization and have, a reasonable expectation that, when you get to the site, it's going to look like you expected. I think very seldom do people wind up building skyscrapers and getting out to the site and finding out like, oh, there's something else here that we didn't know about during design.
Yeah, and actually, one of the quotes that we had rolling early, can't specifically, recall it, but it essentially, the greatest uncertainties in civil engineering are those in geotechnical realm. Mother Nature there is a great deal of complexity, or there can be, and that's where we run into those problems typically, right? So, that is certainly a risk, and being able to identify those risks, and it's not necessarily, on project requirements. We have geohazards as well that can impact those projects. We can have, like, if anybody's familiar with the Pioneer Mountain Eddyville project, that was one of these cases where there was a lot of activity, geologic activity, excuse me, and water, of course, involved in this, and just the complexity of that poses us big challenges.
All right, question number 9. Worthwhile to engage contractors during the design phase to better understand risk. Everybody agreed that it's worthwhile to do so. Statistically, there were a couple outliers there, it looks like. And I think we see the role of this in CMGC. As far as a design method is probably the most direct analog there, but certainly seeking to talk with contractors even for design bid build jobs prior to the letting or in development of the specifications.
Yeah, so for all of you, do you all see, we talked about this topic a little bit earlier about bringing in the contractor into the design, conversation at that point. As a means of reducing risk, is this one of those things that rises to the top, or where is it in the communication part and other considerations of conditions? Is the communication part the big part?
Yeah, I guess I can take the first stab at as a contractor. I mean, generally our feeling is the earlier we can get involved, the better it is, really for all parties involved. We can go from, for instance, having a driven pile or a drilled shaft geotechnical investigation to more of a general one, understanding what's really going to be the driving design case, and helping to speak with agencies and engineers about potential solutions we can do to necessarily meet those. It also helps with forming specifications and developing constructible and fair specifications. In general, we find that it's just been very beneficial, particularly coming from the ground improvement side. A good ground improvement project tends to be good for the contractor. A bad one tends to be bad for the industry. And so in a certain way, we are functioning as kind of ambassadors to this industry. And we want to make sure that the best foot is put forward in a means of seeing additional projects kind of go the way of ground improvement as well.
So this is Steve. I mean, for us, constructability is a central pillar of a design build project. I mean, you have to be in early, and you have to do it regularly, and you have to end with the design and the construction forces aligned. It's just central to being able to come up with the right mousetrap there, and something that everybody believes they can build.
Yeah. So it's high on the totem.
Well, especially for complicated projects or specialty technologies or other things, right? Let's take prefabricated vertical drains as an example. If an owner maybe is unaware, you need to pre-drill due to a dense layer at the surface, and now suddenly you need to do a lot more than you thought you did. That can have relevance, and grouting, whether or not some techniques are even viable. There are certainly a lot of circumstances you can think of as to why it might be worthwhile to engage contractors. Everything from feasibility to things that could be more economical, or how to optimize the designs.
Eric, the mention of grouting just makes me laugh. We had 2 grouting projects. One was like within 3% on grout quantity, but half the number of holes, or we drilled twice as many holes as was in the spec. And the other was the exact opposite. It was like half the holes, but twice the grout quantity.
Welcome to grouting.
Yeah.
What do they call it? Poke and hope?
I recall a personal experience when we were doing a risk registry, and they were sort of nonchalant asking, "What's the probability that the grout quantities will be correct?" And I was like, 0. It's like, they will be different. It doesn't matter what they are; they will be different.
And it's why it's so hard to bid a grouting job, right? Because you have to put your money someplace, right? You've got a certain amount of cost that's going to be there, whether you put any grout in the ground or not. And so it's hard to assign your costs and end up being there in the end, because you end up running over on grout quantities, and your cost distributions are very different than if you don't get to put any grout in the ground. And there's just a lot of risk in trying to structure the bid to be treated fair in the end, or to have a reasonable profit in the end. So,
which I think is a
know what your
good
production is
segue.
going to be.
Do what?
I just said you never know what your production is going to be.
Yeah, you don't.
Yeah, which is a great segue to contingency, right? And sort of talking about contracting and the place it has compared to, you know, what we're focusing on with the A-GaME and defining things, characterizing things early. So, yeah, Derek, do you want to go through these?
Yeah, so we had a majority that felt that geotechnical risk is best managed with a well-written contract. That risk contingency should be included in both the owner's original budget and the contractor's pricing. And then relatively similar distribution about sharing the subsurface construction risk benefits. So if anybody'd like to jump in with thoughts on, I guess, any of those three, or, you know, contracting and contingency or risk management, that's the theme of this slide.
I guess I would like to ask the question is, what is a well-written contract? Does that mean that I've buttoned everything up and all the risk is the contractors now and I have no risk for myself? Or what is the definition of a well-written contract?
That was not the intention of the question, Rick. By the question, we meant that it's fair and shares risk in a transparent and equitable way.
I hope that
That's a good point,
We're
right?
necessarily clear on that.
But that is a good point, discussion point. I mean,
we see as contractors, we see people I say people, we see the majority of contracts are written to give risk responsibility to the contractor.
Yep.
And then that flows down from general contractor to subcontractor, right?
Right.
When it's all said and done. That's the way the intention is in 90+% of contracts we look at, right?
I agree.
Yeah, I was
How do
going
we
to say
solve
there.
So this is Steve again. Particularly in design build jobs, I think the quantity of information is a big factor through here. We certainly see some entities as to where, you know, they want to provide half or less of the AASHTO minimum required explorations at the time of bid. And in those instances, there needs to be some way to incorporate the new information that will be obtained during the design phase of the design build project, as it would reflect the price and schedule and things like that. So something that would be, you know, limiting the information to a design build contractor and then not having a change conditions clause or provision is really shifting the risk strongly to the contractor. The inverse would be that if you have a contract and an element and you've tried to baseline those ground conditions and you have a mechanism with which to be able to include the new information in the design phase of the design build project so that quantities can equitably be distributed, that's kind of the other end of the pendulum swing, in my opinion.
Yeah, when I read this question, I thought you could have the best contract ever, and if you don't have enough geotechnical information, it's the worst.
Yeah. And the owner and the engineer are the primary entities that can influence the quantity and the quality of the information before the bid. The contractors have a very limited ability to influence that. You know, requesting borings and doing things at the end of the bidding period are just very hard to do. And, you know, maybe you address one spot or two spots, but the real focus is starting out at the beginning of, what is the scope and the extent of that investigation. And really, in my mind, the owner and the engineer control that.
Yeah,
I think-
Steve, go ahead.
So I think it's very important for our, the project engineers and the construction engineers the project managers who have, the control of where we do put monies, and it's not as easy as I'm saying, just monies, at Schedule 2, but actually being able to talk to these project managers. I think this is an important message, is that we have the ability of reducing those risks up front during the investigation, but we can't do it doing less than the minimum requirements, much less than, the minimum requirements are tough enough. But being, having a strategic, rational process in determining how we carry out our investigations instead of being very prescriptive and going to the minimum requirements is not the solution. It is being rational and strategically carrying out your investigations to focus on those things that are going to impact construction.
So Ben, there's
And you-
two
and you-
questions
and
from
you-
the chat that I want to make sure get addressed. One was just asked, and one was a little while ago, but I think it would fit in well here. Alan Cadden asked, is the industry in general getting better at providing sufficient data and better quality info on projects? I'm curious for the contractors' perspective on that. Like, have you seen an improving trend? I mean, I know with being involved in the A-GaME, there's like so much like hope and excitement that things are improving, but that's been a relatively short
Right.
That's
It's
been
early,
a relatively short period.
but
so
there
I'm
may be
curious what people
telltales.
think.
I think it's a
I'll
standard
go for-
answer that depends. Go ahead, Steve.
I'll go first. I'll say no. I've said in many instances as a young engineer 40 years ago, my predecessors, I think, did a really good job in the 70s. I think that they had extensive scopes, and those scopes, the number of borings, the number of tests, I think are far superior than what I see in practice today.
And I'll carry that further. And Steve said it in his presentation about the work that they did back in 20 years ago for I-15, how hard it was to get good quality samples and lab tests back then. I would say it's virtually impossible now. That you cannot really get quality samples and laboratory tests to provide meaningful results. And I know that's a strong statement, but I believe it's true. And I've done a similar thing that Stephen done when we had an important project for the Corps of Engineers and sent samples up to Don DeGroot, who was at MIT and wrote the paper with them and had testing done at the University of Massachusetts where he's at. But you can't get good quality samples, and you can't care for them the way they need to be cared and test urgently as they need to be tested in good quality labs anymore. It just can't be done. So the important things that sometimes are overlooked is good index testing, in my opinion. You need lots of Atterberg limits. You need a lot of gradations. You need things for people to be able to compare to the CPTs, to compare to the split spoon end values, so that you can get some kind of coherence between the data. And one of my biggest pet peeves is people running Atterberg limits and no water content. And it drives me crazy how you could sit there and you don't know where the water content and where it falls between the liquid limit and the plastic limit, but we see it often. So it's I think it's a challenge because we don't have the kind of supportive data that we had in the past in terms of constitutive behavior of the soil. You have to make those implications from relatively crude tests, the in situ tests and in the index tests.
Do you think, Rick, that's because just there's not as many people who know how to do it anymore? Like
Yeah.
the labs, the practitioners?
I mean, it's you take the Chicago area, it's union, the whole exploration thing is union now. So you come out of the union hall, do they really care about really good quality sampling? And in labs, running a good lab is an expensive proposition. And if people aren't willing to pay for, a consistent stream of these high quality tests, how can you keep the lab running, right? If there's not a demand for it, they can't stay in business. You can't get quality people to be able to do that job eternally. So there's no momentum to continue to do that. And it's been like that for a long time.
Mhm.
But Rick, and along with that whole problem, isn't it the quality of the employee now?
Well, I think us old guys shouldn't be criticizing the young people, Jim. So
Yeah, we're gonna cut that.
Edit it out.
no, but I think to me it's just you need a lot of momentum in doing that, and you'll still see people coming out of really good teaching programs that preach lab testing and good quality testing and stuff. And the reality is you just can't get it. It's really difficult. Steve talked about the strain to yield, those types of things. If you can have a lab test done now and get 2% strain to the pre-consolidation pressure, I'd like to know where that's being done, because it's really difficult to get good quality samples. So, the geophysical stuff is certainly new. I'm a little bit skeptical. I think you have to have a lot of other data to support it, and then you can start believing in it. It's certainly not going to be reliable on its own. I think in highway work, though, it could be very valuable when you think about refraction testing and that type of stuff, because your borings are so far apart. We don't do highway work. We're going to be in the structures or landslide stabilization and stuff. And there, it comes back down to more conventional things that we need, more of it. And, the geologic framework is absolutely necessary to interpret data. You have to have an idea of mode of deposition and how the ground got there, and then you can narrow the bounds of the parameters that you're looking for pretty good. And then the exploration program is just confirming what you're looking for.
Yeah, it's Rick. It's good that you bring up geology. We were just at an event with our friends from Puerto Rico, and they were stressing the importance of their regional geology and a lot of the issues that they have, particularly with liquefiable soils and other things. So I think a good discussion on the quality and the importance. I was just also going to add in, I think that the engineers and contractors and, hopefully, are able to point out to owners the benefits of doing better geotechnical investigation. I think a good example is like wick drain spacing. If you do some cone penetration tests to find, potential micro layers of silts and sands that could dramatically, change the rate of consolidation, those might be missed entirely if you're doing 1 in 5 or 1 in 10 foot, sort of standard sampling. And think of the time and material cost of, being able to find out that your site is perhaps a lot friendlier than it might be otherwise. Alternately, the other way around. Nobody likes to have a bust where you suddenly need a waiting period that's twice as long with all your structural steel and everything else, laying around just waiting. So I think that applies to lab testing as well.
Yeah, there's a lot of good comments coming in now. People are getting excited. This is wonderful.
Go ahead,
but yeah, so a couple, I'll just note some of them. They're not necessarily questions, but somebody pointed out, Charles Gove pointed out that we are preaching to the choir here, and investigations are going to the lowest bidder. And Alan pointed out that geotechnical engineers can't expect others to make the case here. We will need to be able to explain the need and value or risk to justify a good exploration and analysis program. I mean, this is really what the A-GaME is all about, right? And, we're not as focused on high quality lab testing, but, maybe that should be the next EDC.
Well, so, I mean, to be fair here, I certainly am an advocate for quality investigation and quality lab testing. We've been focusing on the A-GaME, but that doesn't preclude, FHWA's stance on quality investigation and getting quality samples. And, that right now practice is hollow stem auger throughout most of the country, but, recognizing that effect on sampling is not, really there's a trade-off, right? I mean, the speed of investigation using a Holocene logger versus the quality of information that we get with rotary wash. And we do need to preach quality investigations. And so I'm very happy this is coming up, because this, and like you're sort of alluding to, Mary, being part of the second part of the A-GaME. Yeah, you're spot on. I mean, we've been focusing on underutilized methods, but the fact that we have methods that's been used for years and not done to the quality level that we need is something that we need to focus on, and I'm glad to hear it.
Yeah, it all goes hand in hand.
Yeah, I would just do a quick add that we have at Federal Highways been reaching out to different audiences and trying to make a point about not always talking only within the geotechnical community. We've had some webinars with friends in the accelerated bridge construction area, the design build community, and have been working more actively with some of the folks on the construction side to talk about the benefits of both cost and schedule to doing improved geotechnical investigations. So I think we're learning about tuning our message and communicating with those outside our comfort zone.
Yeah, and I just want to add one more thing. I do think it's a real testament to the engineers and the contractors what we have been able to do with the bad or minimal data that we do have, and maybe it's worth it to say, imagine what we can do if we had good data, right. If we had comprehensive data, if we were able to take full advantage of the software and the technology that exists. Exactly. You go from getting a 70% conceptual design at bid to 90 or 95 without it taking any more time or any more of the engineer's effort.
Exactly.
Hey Ben, if I could add one more thing on this, I'm in a better spot now being at Fed Lands, where I can actually talk with the owners, partners that we have. But back when I used to be in consulting, the majority of my projects, I'm 1 to 2 layers removed from the owner, and what I'm getting is a bunch of pressure to reduce my costs. Right. And like somebody else pointed out, generally things are going to the low bidder. That's just driving down the quality in the industry because you've got to stay in business. So, I mean, the message has to get, everybody in the geotech community, maybe not everybody, but the majority in the geotech community understands the benefit. Right. It's got to get to the people that have the money.
That's exactly right.
It's got to get to also, the people, kind of maybe the general civils that are running a project. And again, we're not talking like design build, but just these kind of standard projects that we do. Those folks need to be able to advocate for this as well, because usually they're okay. The owner's beating me up on my price. I don't want to take it out of my budget, but I can squeeze my geotech down. Right. That's usually what we see on that side. So,
excellent point.
Sorry, Ben. About 15 years ago, we were in the preliminary stages. 15 or so years ago, in the preliminary stages of planning our subsurface investigation for the first of our 95 sections, and someone, a structural engineer, and not from this office, but from Harrisburg, actually said out loud in a meeting, "Why do we need to do borings? All the bridges are going to be on piles anyway." and we all just about died.
Yeah.
So there's a lot of different kinds of obstacles.
Yeah.
And did that person get promoted?
If you don't need borings, you don't need geotech, so you can all be structural engineers.
I don't think so, but it was a long time ago.
I think just to circle back to what's on the screen, we have strong agreement. I think this was the only unanimous poll result, that the contractor's experience and engineering skills are a key component of the success of the project. So Not much to discuss there with a unanimous 100%.
We just,
we're all
Kind of a
we just
softball.
want to make sure everybody
does it-
said yes to
Yeah.
that.
How does that
Yep.
jive with low bid?
That's a good question.
How does that jive with low bid?
Hopefully that jives with low bid with the fact that the owner and the geotechnical designer knew exactly what they were doing and specified everything perfectly so that the contractor could build a nice foundation for the project. Subsurface information consistent with AASHTO minimum design requirements is sufficient for a contractor to develop an informed bid. 1/3 agreed and 2/3 disagreed. I think here I would say that it's important to consider that the AASHTO standards do set minimum design requirements. They're not designed to be an average design requirement or an upper bound by any means. And I don't think enough people respect that. I recall on a project where I had said, we're going to need to go above what AASHTO recommends. And they were kind of like, well, why are you doing that? And it's like, because AASHTO recommends the minimum. We're designing a wall in the middle of an active landslide. The AASHTO standard does not cover that. So it's going to be a bit more.
But from the contractor perspective here, and recognizing that that comes out of design requirements, is that sufficient? Is that the way we should be thinking about it?
I think we've heard a pretty consistent.
I think
more
we have.
information is better.
Yeah,
Ben,
right.
Ben's just testing you.
Yeah. I think we have heard this several times, right? And I think we all recognize that is not adequate. There are certainly cases where the risks aren't there and the minimum requirements are fine. But it's where the complexities are there, where those are minimum requirements, and that's certainly the focus of the A-GaME is to look at the risks and having the rational approach.
So this is, I would raise the question is, should those minimum requirements be modified in some way to address some of the specific problems that we've talked about in this discussion, the issues about sampling? Is there a way that we can modify those requirements in a manner that would get us better samples, that would get us better tests? Can we address some of these issues in that mechanism?
And who are you looking to comment on? Because I do have some thoughts on that, but I'm a moderator.
So I'll rephrase that. I would believe as a panelist is that the minimum requirements need to address things like soil sampling and groundwater levels, and to raise the game and to get better information for the bids.
Yep. And to your point, so the minimum, and there's a lot actually going on in AASHTO right now. T15 is meeting right now, and on the design side, there is a concerted effort to look at coefficient of variation for design parameters, but that is completely different than the topics that we're talking here on constructability and the information that we need for making decisions. And in light of that, that is a design document. There are mechanisms that we can actually raise, the focus of these things. In fact, the way we've done it in federal highway from sort of a higher level is that we have, when we're looking at risks, there are red flags that should be raised. And in fact, that's how the minimum requirements started in the first place. It was review of documents. And this document, checklists and guidelines, became the AASHTO. So that was the original purpose, but now we're looking at risk. And in that framework, where we have complex geology, where we have very similar to the original checklist and guidelines, or we have large embankments and we're expecting, differential settlements or settlements, or, in a draw of, doing a roadway alignment and knowing that there's drainage to take care of. Those are all red flags for us to focus our investigations on specific things. And that's not in AASHTO, but that can be in expectations from DOTs in the way they do, with expectations for investigation. And each DOT has control of that.
I think as we move forward into transportation asset management, we're probably going to see risk regarded somewhat differently. That in terms of probability of failure and consequence associated with whether or not things that we are building or rebuilding fail. If there's a small bridge that's a few feet over a judicial ditch with an ADT of 3 and a detour of 1.5 miles, that may have a different investigation or different construction than a major bridge that's a lifeline bridge from for tsunami evacuation or something, or with large number of ADT or interstate highways or other things. And so I tend to think we may start seeing some differences even in the geotechnical area as we look toward resilience, sustainability, and some of the other things that are going on currently. We had a question, or rather a comment in the chat, which I wanted to touch on just a moment here. Have the panelists noted limitations or challenges with standard GINT boring logs, templates, and electronic data? I recall earlier in the discussion, I think somebody had mentioned that electronic data was sometimes difficult to come by. But any thoughts on that?
My biggest complaint about at least the GINT output that we have in Pennsylvania is you're basically taking a typed log and sticking it on a plan sheet. We used to plot these to a common datum and per substructure, and that's not happening anymore. So that visual that you get just from looking at boring logs, which I think contractors probably got more out of than engineers, is missing. It's gone.
I think we are looking at an optimistic time in terms of data and data exchange. There are a lot of things happening. AASHTO adopted a provisional standard, PP 102-20, that talks about the digital exchange of information, which is available for departments of transportation to cite and use today for projects. It mentions the Geo Institute's DIGS XML standard for transfer of data. And I think as we start to see that and some other implementations of BIM and other electronic data for providing plans to contractors for whole projects, grading, geotech, other structures, that we're probably at the beginning of a digital revolution. And Sarah, I think actually PennDOT is leading the way with your digital 2025 initiative to.
Yeah, it'll be good to see what we can do with all that data, how we can manipulate it in a way to be more beneficial and useful to all parties.
Yeah, so I mean, just from the practical side on the contractors that are here, and this is not a new thought either, but the fact that what is your, if you could get electronic data, if that was a requirement, which PP 102 could make that a requirement, that's exactly what it says. Is that a value to you for bidding for?
Yeah, I mean, absolutely. I mean, I think it's like what Derek said. I mean, I think we're just really at the cusp of this taking off, right? Like Solitanche internationally has a Google-based database of all geotechnical information all over the world. We have our part in the United States, the projects that we have, but typically it's PDFs. You go into files in PDFs and looking up PDFs, right? You're not getting access to the digital data. But
Right.
that being said, the various departments of transportation across the country could have or do have oodles and oodles of information that, you know, as taxpayers, there's no reason why that couldn't be available at every, you know,
Right.
latitude
It's
and
public
longitude,
information.
public information. And, you know, you start looking about the efficiencies of bidding work, or, you know, just initially estimating the cost of work for depths to rock, what the overburden materials are, all those things. There's just so many benefits for us as a country, like because of, you know, reducing maybe the costs and risks in infrastructure. I mean, there's going to be valuable tools, you know, but as far as getting the electronic data, we always like to have the electronic CPTs, right? Because you can look that up, and there's so much of analysis you can do with a CPT because of all the various correlations that are there for CPTs. And so getting that in a PDF is a very frustrating thing, and you typically have to beg for the digital data. But yeah, I agree, we're right on the cusp of it. And it's not only it's also just the equipment, right? Equipment, the sophisticated equipment now is measuring torque and down thrust and
Right.
and all kinds of things, and it's recording it in real time. And so the different contractors are going to have that kind of internal information. The equipment manufacturers are probably recording it themselves too, so they have it all as
Right.
well. And so all of that's going to be available. And I think 10 or 15 years from now, it's going to be a very different time when it comes to having an understanding of you know, historical ground conditions.
Yeah, absolutely. And you know, one of the A-GaME technologies is measurement while drilling.
Yeah.
You know, from the geotechnical investigation side, you know, the industry, foundation industry, they've been doing this for a long time, and other industries have been doing this for a long time. But now we're, you know, looking at doing drilling, measuring those parameters, and I think you're spot on. I think this is valuable information. You know, once we're able to, you know, take the drilling equipment, you know, and make those relationships between the bit and the drilling system from site investigation to what we're doing in construction, that's going to be a big help.
So for many of our projects, the information will go into a 3D software program, a microstation or something like that. And anything that can facilitate bringing that information quickly into that kind of a way of looking at the information would simply save the time that it takes to take it from a piece of paper and to put it electronically.
Yep. Huge cost savings, and you know, type of quality of work that we're being paid for.
Yep. One of the thoughts that was also in one of the chat questions was about missing information, how if templates weren't modified for data needed, such as full rock descriptions, hammer calibration, and other metadata, you know, that certain things could get lost if you're including simplified logs in the plans and other things. But hopefully, as electronic files become the norm, you know, we'll be able to capture all the information that sometimes gets lost, including, you know, driller notes and other things like, you know, 15-foot artesian or cobbles, lots of cobbles or other things that can make constructability, you know, a problem. We've got a limited time left,
Yep.
So I think we're going to ask each of our speakers for a closing comment in order to give them just a little bit of time to prepare for that. I'm going to bring up a couple of informational slides that Ben can go over here. So be thinking of your final statement as we share a bit of information about upcoming events.
Thank you, Derek. Yeah, so just for your information and resource that we have available, be aware that we have a new website, and you see the website address there. We've got a lot of new content that I think actually can help with some people who are not necessarily technical. There's some great videos that are coming out. We've got at least one out. I don't know if the rest of them where they're falling here, but they're very informative. I think people who don't necessarily, the project managers who aren't geotechs and need a little more visual, for this discussion. They're fantastic. So check those out. If you're wanting to sign up for additional information, you can sign up on the website. I think we used the Gov delivery system. Most of you are in that system, but we can sign you up for newsletters if you're not currently engaged or getting those. So another point that's not here, but DFI has been a tremendous partner. We have some user groups, 3 user groups, one for geophysics, one for measurement while drilling, and one for CPT. And I encourage you to get involved with those groups. DFI is helping us with some of the coordination on and communication on the web, and DFI's subsurface characterization committee has some information there that's very helpful. Next
I'll
slide,
link
please.
to that,
Okay,
the
go ahead.
subsurface characterization committee as well here.
Oh, very good. Thank you. Which Mary is the chair for. So fantastic. Our next session is going to be on July 20th, and we're going to start looking into the geotechnical uncertainties. So we're going to get a little bit more technical than the discussion here, but I think this really helps us, as we synthesize and get to a point where we want to make this happen and we want to solve the problems. This part is certainly the technical part on geotechnical uncertainties and how we can characterize our sites better to reduce those uncertainties. And so we're going to look at the problems, we're going to look at some of the solutions, present some case histories, and have a discussion there. So please join us for our next session, July 20th, at the same time that we started here at 11 a.m. So yeah, final thoughts.
I guess we can start in the order of our presenters this morning. So Steve, parting thought?
We like piezo cone data, and we would love to see an opportunity as to where that could be always presented in an electronic manner so that we could get the numbers to be able to process it.
All right, thank you. Jim?
Spending more money in investigation will take and reduce the owner's cost in the end. Because when we have a problem and we can't solve it, you know who we go to. There's another party involved. It doesn't end this discussion.
Point taken. Thank
Yep.
you, Jim.
Brian?
Yeah, so I guess I would end just by saying I think it's a very exciting time to be in our industry. Geotechnical engineering is only about 100 years old. We're kind of fighting up against 10,000 years of human infrastructure construction. So we have to be great salespeople. I think the best place to start is with good information. I don't think we have to necessarily recreate how we contract work, but I think as good information is presented to contractors and subcontractors, the cream will rise to the top, and we'll start seeing it pay off in projects down the road.
Cool. Rick?
I think that it's really important to mesh design with constructability, right? That can come through different types of procurement, but if it's not, if it's going to be design, bid, build, then I think that it's important for you to get your young people on job sites to do that. That has to be a priority because they just got to see how things are built and the challenges of the job site because they're real. Get lots of index tests. Somehow we've got to be able to correlate all the things that are out there. And I agree with Steve. I think CPTs do a great job of supplementing SPTs because of the continuous sampling. So if the cone will go in the ground, push it in the ground.
Okay, Peter?
Well, I'm the contract guy, so I'm not going to have necessarily a direct geotech thought. But the one that comes out today that kind of sticks with me is just, if you're having the complicated projects, especially if they're geotech, hold those early information meetings, hold, the one-on-one conversations, listen on both sides. If the contractors are telling you there's an issue, try to upgrade the testing, try to provide what you can, try to make some different allowance in the contract. Even if you can't do it on that contract, keep it in mind so you learn next time and don't make something awkward coming back again. And vice versa, try to make that make good people available and kind of be a trusted partner, so they're willing to tell you and kind of have the conversations. If you're having good conversations, eventually most of the stuff will work through, at least on the procurement contract side.
Okay, thank you. Sarah?
I'm gonna tailgate on what Peter just said. I think I said it earlier, relationships are enormous. And not only do they build trust, but you can learn so much from the people who build things. So that design construction relationship is absolutely critical, no matter how good or bad a project is going or design is going.
Okay. Yep, Dustin.
Yeah, so I think there's like a million things I could talk about with this. Just pick one. Kind of what I was mentioning earlier. It does start with the owners, because at the end of the day, they're the ones kind of paying for everything. And I think if we're wanting to do the appropriate, the correct, the best geotech explorations, get the best geotechnical data that we can, the message has to make it to them somehow. That's where I think there's been a big missing link in our Fed Lands projects. We work really closely with our federal partners. They know us, and I'm a PM, but I have a geotech background. They know me, they trust me. They will, they'll trust that we're making the right recommendation when we say we need to do a little more testing in our geotech project. So I think that's where we need to put a lot of effort.
Great. Thank you, everybody. This has been fantastic, and I love the closing thoughts here. But thank you, speakers, and thank you, peer contributors, for making this successful. And we want you back, for further sessions. But thank you, everybody, for joining us. Feel free to give Derek, myself, Silas a buzz if there are any questions that we can help you with. Thanks, everybody. Take care.
Everybody. Take care.
Thank you, Ben, and everyone else.
Yeah.
Bye.
Good meeting.